Now, please tell me that you see a red dot that indicates that this session is being recorded and we are about to begin. So, welcome everybody. We have the quorum, and we are about to start Cloud Bootcamp, which is the work that we do in this segment. This segment comprises of 3 parts. These 3 parts you already know are technologies, DevOps, and architecture. The first segment is technology segment, which is a horizontal breadth coverage of the industry. The second one goes deeper with operations and developer operations tools like Chef, quite a bit. And it is nice hands-on perspective on how people think, people and teams develop things together and roll it out to an end customer. So it gives you good exposure in terms of what DevOps is and how these tools are getting used in real life. You can actually make them and apply them for a given context. And many of your employers actually are using these tool sets, and you want to be able to learn these and apply that to your context, to your current employer, to your future employer, to your consulting client, whatever the case may be. And that is going to be the depth discussion in the second segment. And the third segment, we'll go again back a step and focus on business, understand customer needs, understand what that customer situation is, and how do we solve whatever the customer problem is, given our understanding of the cloud technology set and the operations and tooling that we will put together in the second segment. So first and second, combine and apply that in the third segment. That's what we intend to do, and I'll talk more about that as we proceed along. Today we begin cloud technology segment. This will be these dates that you probably already know: Monday, Wednesday, Friday. So I'm just jumping on with certain assumptions that you already know the dates and times and everything. Please remember to put a calendar entry for yourself for 4 o'clock Monday, Wednesday, Friday, and things like that. So mark your calendar according to that, and let us proceed. With that understood, I want to make sure that you go to the cloud technology segment and read it on your own time, not right now. Not right now. Right now you focus on whatever we are doing together. And I'll kind of sort of follow the same outline mentioned here, but not necessary. It is not necessary that we have to follow this, because I don't want to bore you. What does that boil down to? If you want to bring something up that is relevant to you, to your work for right now, you should. And we will discuss that instead of this boring old thing that is written down here. So be flexible. It is not a rigid curriculum, because I get to decide the curriculum. It is nobody else decides. You and I will together decide what do we want to discuss, and we will work exactly on that. We'll also use open source projects, a lot of them, because that is what this program is about. It is about open source, and we will use that as our focus as we build things, as we learn things and understand. So now let us begin from the fundamental concept, really, really basic. What is this program? It's about cloud computing. So what is cloud computing? That's what I want to focus some time on, go in depth, and ask you, what do you think is cloud computing? So let's begin with that. Any one person, whoever volunteers, one person, just tell me, what do you think is cloud computing? Anybody? And you can unmute yourself. If you want me to unmute everybody, I can do that. Or if you want by the way, if you make noise, I will mute you. Just want you to know. So you can always unmute yourself, but if I am hearing that somebody is making noise, I will mute you without telling you, just telling you that. So open your mic and speak. Anybody, the first one. What do you think is cloud computing?
I think it's a bunch of applications on a set of servers, and you access the apps by going to the servers. So the cloud's nothing new. It's just a whole bunch of servers out there.
Yes, right? Cloud is nothing new. Absolutely right. Cloud is not new. And so the problem with your definition or with my definition is that it is your and mine. It is not authentic, right? So what is the authentic definition of cloud computing? Who decides that? Who defines it? There has to be some authority that defines it. So who is that authority? Is it Microsoft? Is it Google? Is it Amazon? None of that. So who's that authority? Do you know?
IEEE?
No.
I don't know.
So it is our NIST. So the authority is this: National Institute of Standards and Technologies. It is the US government authority that defines standards. And so these guys have decided to define what cloud computing is. And so it is beyond doubt. That's the formally accepted definition. So let's go search for cloud computing definition. And so just adjusting a little bit. Here we go. Okay, definition, NIST. And so here we should be able to find what the definition is. And so these guys have put together a long, boring PDF file. And it is a good reading when you're feeling really sleepy. It helps you sleep faster. And that is the document right there. So you download it, print it, bedtime reading, not right now. And so that's what I will do, is actually focus on, zoom in on the exact thing that I need for us to read. And so I'm going to open that PDF file in a new tab and grab the definition. Come on, PDF. Okay, there it comes. So here's the definition. And let's go focus straight on the meaningful material part instead of boring through this 50 pages of blah, blah, blah. So let's focus on the exact definition language. It's right here. And just read this one paragraph. That's it. That is the definition. And so I'll read it with you, and I'll focus on making sure that all of us understand it. So just adjust it a little bit, and there it is. So it says cloud computing is a model. Actually, let me zoom in on exact portion that I want to read. And that is the 3 lines. So cloud computing is a model. Model for what? Enabling something. Something what? What is that something? It is providing on-demand access to a shared pool of resources. That's what it means. So on-demand network access to a shared pool of what? Shared pool of configurable computing resources. That's what they are really talking about. And what are computing resources? Those resources are like network and storage and servers and application and other services. You want to make them available on demand. What does that mean? I want it right now. I should be able to get it. Like, I want a computer right now. How do I get it? I go here, on demand. So I feel like I want to get a new computer right now. I log in and I type my authentication and I put the plus sign to deploy a new machine. I want it in Seattle, and I want it to run Debian OS version 9, and I want to use my key, and I want to use this firewall, and I want to call it whatever I like. That's the name. And so I am going to start this machine. I'll pay maybe $5 per month, small size machine, and I will say deploy now. I just started a new machine. That's what on demand literally means. I want it, I get it. So I got a machine. The machine is called whatever I like, and it's a Debian server running in Seattle, installing right now, and in a minute or so I should have access to it, and I will wait for it to finish installing, and I will actually access it right now as we speak. So go back to the definition again. So it is on-demand network access. I am connected on the internet. I should be able to get that access to the machine on demand. It is shared pool of resources, meaning you and all of us and those people out there on the internet, anybody can also get similar resources, because these actually these machines are shared among other people. So you can carve out a portion for yourself, and you're sharing the bigger boxes among various people. So it is a shared pool. So let's go read that portion. It says shared pool of resources. It is a configurable compute resource. I can configure it. I can make it small, make it big, make it open this port, open that port, define what exactly I want, and then allocate it on demand whenever I feel like. And so when I feel like, I get a machine. When I feel like I don't want it, I can get rid of it. And so if I don't want it, I get rid of it. I stop my bill at the very same time. So now let's read these words very carefully. Ubiquitous. It means I can be in Zimbabwe or India or Sri Lanka or wherever in Seattle, and I can still get access to those as long as I am on the network, which is the internet. And I can get them on demand. Convenient, meaning I don't even have to make a phone call to the service provider. I just went on the website and said, click a button, and I got my machine up and running. Let's go find out its IP address. It's right there. I'm going to copy the IP address and open a terminal and make the terminal big so you can see it. And then connect to it like that. And I am connected. Here we go. That's the machine. It's the Debian machine called Whatever I Like. That's one I created. And I am paying $5 a month. I have the machine on demand. Now I'm in a mood of getting rid of the machine because it is something that I don't like anymore. So I'll say, you know what? You machine, go away. So I can stop the machine, but stopping does not stop the bill. Remember this. Stopping does not stop the bill. It merely means you have a resource allocated to you. It just is not running right now. But it is reserved for you, meaning you have to pay for it. That's what stop means. So stopping doesn't do any good to your pocket, your bottom line. It just stops the machine. It's like shutting down a machine. So don't confuse between stop and terminate. So now I'm going to terminate the machine by clicking the manage button. And in this particular cloud, they don't let you kill the machine within first few minutes of activation. So we'll come back in a few minutes. But other clouds will let you kill immediately. Like you start the machine, you're done with it, you kill it, that's okay. Not in this cloud. So this particular cloud has some conditions. You have to wait for 5 minutes. And that's okay. It's just their program. That's how they're written. So that's this company called Vultr Cloud. I don't know how to pronounce the name right, but it is VULTR. It's a good cloud. I use it. Right now I have some 3 services running already there. And I just created a 4th one. I will extinguish the 4th one, which is called Whatever I Like, which I don't like anymore after 5 minutes. Back to the definition. It is convenient, on-demand, network-based access to a shared pool of resources that are either networks, servers, storage, application, and services. Those things are your network configurable resources that according to the definition. You can rapidly provision them, meaning you click a button, it gets provisioned, and you release them with minimal management effort or service provider interaction. I don't have to call Vultr to get rid of the machine. I don't have to call my IT department to allocate a machine. All I need to do is promise to pay. My promise to pay is $5 a month. I got the machine. I'm going to pay them $5 at the end of the month. Only if I use the whole machine for the entire month. Otherwise, I'll pay only something like this. How many hours in a month? 750 hours. So for example, I use this machine for 1 hour. So I'll pay 5 divided by 750. That's the amount of money. So it's like 0.06 cents. It's not 0.06 cents, it's called 0.6 cents. That's the money I actually wasted in this quick demonstration. I'm probably going to use this machine for 1 hour or less. And once I'm done with it, I'm going to kill it. As in, literally use the word destroy or something like that. After they let me destroy, they have a 5-minute blockage. But we'll come back to the destruction part later in the next few minutes. Now, you got the point. Released with minimal effort. Literally, the effort it takes is simple. Run an API call, click some mouse. That's the amount of effort needed. It is programmatic, and you can get access to on-demand resources, as you saw this example. We'll do tons and tons of more examples like this. And that is how these guys define cloud computing as the opening line. There are 5 more things to it, and we'll talk about those also. And there are 5 things here mentioned. There are 5 essential characteristics. Those characteristics are, first one, on-demand self-service, meaning I don't have to call somebody, hey, can you please get me a machine? No calling needed. Just click a button, API call, one of those, and it is on demand, available at your service. You decide when you want it, and you decide when you don't want it, and you're done. That's on-demand characteristic. It's one of the 5 key characteristics. That's what defines what a cloud is compared to something else. So now you can, of course, read these definitions all day long, but I'm just giving you a nutshell summary of these things so we can move on faster ahead. So on-demand self-service, I think you got that. Anytime you have a question, you should ask me. Anytime you have a question, unmute your mic and stop me. Hey, Nilesh, please explain that again. I did not understand. And that is welcome. I do not feel interrupted at all. As you will notice, I do not use a PowerPoint slide deck to walk me through this versus that. I don't have such a thing. So there is no such thing as interruption to me. You can anytime feel like, hey, I didn't get that piece. Can you go back and show me that or show me this? That is totally welcome and highly encouraged. In fact, if you don't do this, I'll get bored. I'll be talking all day long. That's not what I want. So I want active participation and I encourage that. So please do that. Okay, now next one, broad network access. What do they mean by this? It basically means that if you are in a place called the Mount Rainier National Forest, where you sometimes do not have network access, in the backcountry, or you're backpacking somewhere, you cannot really provision these services. You have to have network access. That's what it boils down to. And once you have access to the network, you can provision it through thin client, thick clients, all sorts of things. And bottom line, in this particular characteristic, the assumption is that you have to have access to the network, typically the internet. It can also mean your internal private cloud or internal private network. It's just basically saying that you have to have access as some way of connecting to the resource. For example, in Boeing Company, you have OpenStack deployed. So you have to have an access method to get to your OpenStack. Otherwise, how will you connect? If you cannot connect, you cannot provision, you cannot destroy, you cannot use. So you have to have network access. Next characteristic, resource pooling. And this pooling basically means sharing. What does that mean? It means somebody else is also on the same physical location as you. What does that boil down to? It means this machine that I have, called the whatever I like machine, is a machine that is a virtual machine running in some cloud, Vultr cloud, in some location in Seattle. Which means if you pay them some money, you can also get a virtual machine in the same physical location, possibly the same physical box. And it is hard to comprehend unless you have seen what I'm talking about. So I'll draw a picture for you. And what I will do is I'll describe what a typical scenario of a cloud deployment is. So when I say this, whatever I like, this machine that I have created, I hope you can see my handwriting. If you cannot see it, please tell me. Now this machine I created with like 1 GB RAM, and I pay them $5 per month, and it has access to a network, and I have the IP address, and I am connected to it from here using SSH method, and I am connected like this. You can see that I'm connected to a Debian machine. I sometimes type random commands on the command line, but don't get too scared. It's not too complex. I'll tell you what to do with these commands. So you can see that I typed this command to get the information about the operating system running. And so I found out from that command that what is the operating system? It is Debian Linux. Whereas in this terminal, you can see that the operating system is my Macintosh. It's the Darwin kernel. So two different machines. Yes.
Nilesh, can you do a df-h just so I can look at the files?
Yes.
Got it. Thank you.
Okay, so the idea behind this is that we are connected to that Debian machine, and so this Debian machine actually is a machine with about 1 GB RAM, right? It shows that 1 GB RAM. And so back here, This machine is 1024 MB RAM, same machine. Now this is constructed out of a large box, a really large box. Sometimes it can be as big as a gigantic box of say 256 GB of RAM and some terabytes and terabytes of 100 terabytes of storage and lots of CPU. And so this gigantic computer will run Linux or some other machine, some other OS. Maybe it can also run Windows. And then using that underlying OS, you will then divide this machine into smaller parts. And this concept of division, you keep dividing a machine into small parts until you get a part that is still usable as a small machine, as a small virtual machine. And that is kind of sort of what this thing is. I have taken a virtual machine in a big gigantic machine somewhere in the Vultr cloud right here. So there is a location somewhere in Seattle and in all these locations as well, where they have big boxes running hardware, running their big gigantic machines that they partition and carve out smaller chunks. And you get to decide how much money you want to spend, and you get to decide which operating system you want to install, whether it is Windows or Ubuntu or Debian or whatever, and how big the machine you want it to be. Is it $5 machine, or is it a $640 per month machine with 24 CPUs and 98304 MB of RAM? So it depends on how much budget, how much need you have, and then you can carve out a big chunk or a small chunk of the big gigantic machine that you have. So you can get a big size machine for yourself, this big, and you pay them $320 per month. Whereas in my case, I pay them $5 and they gave me a small little piece. And that's okay. Now back to the definition. In our definition, we are looking at shared pool of services, right there, resource pooling. That means you can get a machine on the same box where I am with this machine. Maybe you got this machine for $10 and I got this machine for $5. And so we are coexisting on the same physical machine. That could be possible. It is shared among users, among public. What does that mean? It means if you have a company A and your competition is company B, company A and company B can actually reside on the same box. Could be possible. It could happen that these guys decide to get a $5 machine and these guys get to decide to get a $10 machine on the same box. And they are competitors, like Coke and Pepsi, for example. Could be possible, Pepsi. So two competitive companies on the same shared resource. Does that scare you? It could scare some people, saying, hey, my competition is in the same box. What happens to my data? It could scare people. But let me tell you that there's nothing to scare about, nothing to worry about, because these things are isolated from one another. So there is no way for a machine that I create to connect to a machine that you create, even if it is on the same physical box. It could be a different box, could be a different location, could be a different building in Seattle, could be a different city, could be a different continent. But there is no reason to worry because it is isolated through hypervisor isolation. And we'll talk more about hypervisor isolation, virtualization, containerization as we progress along, but I'm just telling you concepts that they're isolated. Back to the definition. Resources are shared, they're pooled. So there's nothing to worry too much, but some big companies worry about it. So they want private dedicated cloud, and that is also possible. You can get the entire box dedicated to your company. That is also possible. You have to pay more for it. As long as you're ready to pay, some companies will acknowledge and allow you to make that happen. In those situations, it's called single tenant model. Whereas I'm talking about a multi-tenant model, multiple companies renting the same resource. And I just use the word renting because that's exactly what cloud computing is. in a simplest, in my definition, cloud computing is like renting computers, effectively. You rent a car, you rent a computer, call it a cloud. That's it. That's what cloud computing is. Somebody else's machine, you happen to use it, you call it cloud computing. That's the simplest definition I can think of, but nobody cares about me. They care about this definition. And so let's go move forward. Rapid elasticity. What does that mean? It means if I want 10 more machines, what I can do is I can, maybe select Debian again and go to Seattle and select $5 and select my key and select my firewall and give it a name and say I want to get 9 more machines like that. And there we go. I'll name them all. Sometimes I don't even have to name them. They'll randomly assign a name and I deploy and I get 9 more machines. As simple as that. As long as I'm ready to pay $45 a month more on top of what I already pay $5, I'm okay, they are okay. Rapidly scaling out. I can scale very easily. Grow big, grow small. How do I grow small? I go to my machines I have right there. And this whatever I like is the one I don't like anymore. So I say that, I want to get rid of this machine. So I get a delete button and say, yes, I want to get rid of you and make sure that you don't delete the other machines, but only the one I really, really want to delete. So I want to make sure that I'm deleting this, whatever I like, and say yes, and say okay. And the machine is gone. And my bill stops right now. So I have managed to lose 0.66 cents in this demonstration. That's okay. But just saying, it is tiny little piece of money that you wasted or maybe used for a purpose that I had. I had a purpose to demonstrate to you. So I did that. So that's how people can use the machines that you want on demand, basically. The idea is rapid elasticity. You can grow and shrink as and when you feel like. It also comes with a illusion. This illusion is what I want you to understand. This illusion is that of infinity. But let me tell you, it is not infinity. But the cloud companies tend to create an illusion of infinity for all of us. And that's a good thing. But we need to know that it is not infinite because nothing is. But they create that illusion that, all of us can randomly create any number of machines as you like, as you grow, as you want, on demand, rapid elasticity, rapidly growing, shrinking as you feel like, and they will never run out of resource. That is not true, actually. Sometimes they actually do run out of resource. Let me show you some examples. Another cloud. I'm logging in. This company is called DigitalOcean. It's a smaller cloud. And I go to these smaller clouds because they are not too complicated. They are simple demonstrations. So it's easy to demonstrate. There are not too many bells and whistles floating around compared to AWS or Azure. There are too many things floating around. AWS.amazon.com. We'll get to those also, but I'm beginning with simpler examples. So if you go to Azure or Amazon and log in, like here I'm going to log in, sign into console, and then I log in. It will be daunting at first sight because if you haven't seen it before, there are too many things to deal with. And so that can be a little bit of challenge, but I'll show you both. Let's begin with the simpler cloud first. But here are the choices. It goes on, and so it can be daunting. So I don't want to go there right now. I'll come back to it. Let's begin with the simpler cloud. And in this cloud, these guys have a fancy name for machines. The company name is called DigitalOcean. DigitalOcean LLC. And so in their ocean, they have these droplets that they call computers are called droplets. Yeah, well, you can call it whatever. It's a virtual machine, basically. And so they call them droplets, and I don't care. But it's a good branding. And so I can create a droplet. I can choose the operating system I want, and I can choose the size I want. And sometimes I get to choose my data center. I decide that I want to get a $10 machine, which is basically 1 GB RAM, and I want to put that in Amsterdam number 1 or New York number 2. What happens? I cannot. Whatever happened to the illusion of infinity? It ran out of space. So the Amsterdam number 1 is gone. New York number 2 is about to go. It's full. It's not there available. So due to limited availability, we have temporarily disabled droplet creation in New York number 2. They tell you that, and that defeats the idea of illusion of infinity. But that's okay. It is still a good cloud for me. I hope you might like it or not. I don't care. But the idea is that they did not give you the illusion of infinity. Some clouds do, like these guys, big ones. They give you illusion of infinity. You can create as many numbers as you like, but sometimes they actually don't. So let's go to the cloud in Amazon and we try to launch an instance. And we'll say that I want to launch a Ubuntu server. And here, I will select a machine called T2 Micro. And then I will say configure the details. And I'll say I want 100,000 instances. I will not click the button, don't worry. But I'm just saying that you can. So it says that, 100,000 instances, they will actually let me create. Because I have my account with them for I think 8 or 9 years. Ever since Amazon started, I have been using it. So they have given me permission to create a large cloud if I want to. But newer accounts are typically not allowed to create big, gigantic resources like that. And so all of you should open an account with all these providers that I'm describing to you. But remember to use the free offer that they have. And I have a list of all these free offers in one shot. So go to this site and there go to a place called, it's coming up in here somewhere called Cloud Services. That's where I have accumulated a bunch of free offers for all these clouds that I mentioned. So Amazon gives you 1 full year of free usage through that link. Google Cloud will give you $300 through that link. Giant Cloud will give you something for free. DigitalOcean will give you something for free. Azure will give you $200, $300 for free. So go through those things and you will receive free stuff. Use it. Why waste money? Don't waste money. You have to give them a credit card and establish an account through these links that I have here on this page called Cloud Services. And sorry, FAQ Cloud Services. That's where the link is. And through that, you can open accounts. You can do it later, but do it. It will be nice to get exposure hands-on with these cloud companies. So we'll close it right now. I'm not creating 100,000 machines here, but you can. Sometimes they limit you because you're new to them. Sometimes the cloud companies got run out of space. So that is defeating the illusion of infinity, as is kind of hinted in here, is rapid elasticity. My computer is telling me that my internet connection is slow. If that is the case, you should face trouble in hearing me or seeing my video. And if that's not the case, I'm going to ignore that warning. I'm apparently getting a warning saying that my internet connection is unstable. If you are perceiving any problems, please tell me. Okay, moving on.
Fine for me.
Sweet. So next thing, the 5th characteristic. That is the most important characteristic. It basically means measured service. It means if you use something, you are going to pay for it. You are going to get a bill. The bill can be as small as $0.00666, which is 0.6 cents. But remember, you will get a charge because they are metering it, they're measuring it. You consume something, you start a resource, you provision a resource, you are going to get hit with a bill. No doubt about it. That's what this means. You use it, you pay it. And if you stop using it, that doesn't stop your bill. You have to extinguish the usage, kill it, destroy it, and then the bill stops. And that's what measured service actually means. Now, those are the 5 characteristics. on-demand self-service, network access, resource pooling, rapid elasticity, and measured service. Now let us, there comes Travis, disappeared and came back. So now we will discuss the 3 types of service models that are the next on the agenda here in the definition. 3 service models, and then 4 deployment models. And that concludes the definition part. So we'll go through these things quickly and move on. 3 service models. It is not just about machines. That's what it means, these service models. So you can get a server like I showed you, but you can get other things. What are those things? Sometimes you get storage. Sometimes you get applications. Sometimes you get other things from companies that give you services, and you use them and consume them. And that's what this service model comes into play. So the idea of service models, there are 3 core types of service models defined in this definition. Those are, you probably heard of it: infrastructure as a service, platform as a service, software as a service. Probably well known. I'll give you my perspective on these 3 things, and there is a definition up here. Of course, you can read that, but I will not make you read it. Instead, I'll describe what I mean by that and what these guys actually mean by that. So let's go take a new piece of paper. And am I in the right notebook? Yes. So I'll put a new sheet of paper, and in here, I'll describe what I call how money flows from one company to the other, and all the way from a customer all the way to the suppliers of things. So if you were thinking of what I call, by the way, another thing I wanted to make sure that I remind you, I have this bad habit of not taking breaks. And I go on talking for 5 hours and I forget that it has been 5 hours. So if you need a break, you need to tell me that, hey, we need to take a short break, and that is totally okay. So anytime you feel like now is a good time to take a break, please speak up and ask me to stop for 5 minutes, 10 minutes. We take a break, we come back and resume. Otherwise, I have made sure that to make you remind me, I completely forget when I'm talking that there is a need for biological break. Completely forget that. So don't make me inflict myself on you. If you want to stop, please make me stop. And I just wanted to tell you that, because you should feel free to stop me anytime. Okay, now these 3 things: infrastructure as a service, software as a service, and platform as a service. How do we really understand it? Let's get to that. So imagine if I am making if I'm a customer here and I want to buy a laptop. So what do I go? I go to, say, Best Buy or Amazon, and I buy the laptop. So there's the laptop. Now, who makes this machine? It can be a Dell laptop or something like that. Dell, IBM, all those guys make it. Lenovo laptop. So, but honestly, this company doesn't really make laptops. The companies that actually make those laptops are called Compal or Quanta or Flextronics. Those Taiwanese companies, they make these machines, and these guys just put a sticker on top. And so these Compal, Quanta, and all these guys are ODM. These ODM companies, they rely on other things from down below to give them what? They need RAM, they need CPU, they need disk, they need SSD, they need other things that go along in building those components together to construct. They need motherboards and other things needed to make things happen. And then these guys also need to add something else called the operating system, like Windows, or sometimes it is Macintosh. In that case, these guys don't exist. This company makes it. Macintosh, Apple will add and then give you the Mac laptop. Or sometimes it is none of these guys and you just add Linux OS, like one of our friends is doing right now. Travis is running an Arch Linux box. He's hardcore. Travis is running a Linux machine to connect with this conference, and he's a fan of that, and I admire that. But not everybody is like that, right? He builds his machines and he's setting up Linux on his own, and that's I call it crazy because I am like that. So
Well, thank you.
yeah, some crazies do it like that. So but back to here in our picture, what we are looking at is another sheet of paper, is people who make, say, a CPU. Those guys are called Intel, for example. And so they give the CPU up to the ODMs, and the ODMs will give a reference design to somebody like Dell. And then Windows comes along, Microsoft, MSFT will give them Windows license. They will add these things together and prepare a laptop, and they will sell that laptop to you and me, and this is me and you, and we give them money, and this money goes to Dell. A part of that money goes to Microsoft, a part of that goes to ODM, and a part of that goes to Intel, and things like that. So the money is kind of flowing downwards, and the products and components are going upwards. So that's the flow. And so very, very similar to this game is how this infrastructure as a service, platform as a service, software as a service game also flows pretty similar to what I just described. Let's go draw that out. So at the very end usage scenario, you have end customers who will use some services. And these services at the very top level are called software as a service. And I know pretty sure that all of you and me use these software as a service, or rather I should reword it, use software as services from a variety of companies already. We do that all the time. Right now, I am using the OneNote service from Microsoft, the Zoom software from Zoom company, and a bunch of other things are running at this moment. So those are the software that I'm using, OneNote as a service, and I'm synchronizing those notes with you guys, all of you. So that service is running. That's the software that I'm using. So it's a software available to me as a service from the service provider called Microsoft, or the service provider called the Zoom company for our video conference. And that's the services that we are using. But under the hood, these software makers, they're called software developers. These guys need some back-end platform. And they will use that ready-made platform so that the work of the developer of these software makes it easy for them to just readily use the platform and focus on improving the capabilities of OneNote, or improving capabilities of Zoom, or other software that the software developer is making. And they pay money to the platform, and they use that platform. And this platform in turn makes it easy for the developer to develop software. So the benefits go up, the money goes down. That's how you think about it. So this end user customer is using services. They pay money to the Zoom company like I do. And then Zoom company in turn will use some platform to run the Zoom stack. And they might pay some money to the platform company, and we'll go details about which exact platform company a particular application uses. But in general, every application that is running out there in the cloud in form of a service uses some kind of a platform. So there are these platform developers. Platform developers. These developers are different from the software developers. And these guys develop the platform. And so what they do is that they need underlying infrastructure. So they take the underlying infrastructure as a service, and they pay them money. And they use the underlying infrastructure so that it becomes easy on the platform developers to develop the platform. And this thing goes on. So you have software as a service, you have platform available as a service to the software developer, and infrastructure available as a service to the platform developer. And these infrastructure as a service companies, they also need some help. So what they do is they pay money to people who make hardware. makers of hardware. And they get hardware from them, and they put things together in terms of big, let me show you some pictures. Data center, you've seen it, you have it in your companies and things like that. But I'm going to just pick up some data center pictures and describe to you. So here is an example of a Google Cloud. They're building a data center for Google in Alabama, and they're spending $600 million on what? On this thing. What is that thing? Oh, I think I clicked on the wrong button, but this thing. So what is this thing? If you carefully look, it's got some kind of a rack, some rack containing either networking gear or CPU or storage or one of those things. So who makes these things? Typically your usual suspects from Taiwan. That's where it's made, most of it. Most of hardware is made in Taiwan or China. And that's where it comes from, and it gets deployed in data centers like this. And so these guys are basically paying them money for the infrastructure so that they can receive the hardware and provide infrastructure as a service to the platform developers. So the money transaction is very simple. At the very top, you have consumer, like you and me. You pay money to software as a service companies, and these software developers, they develop software. These guys pay money to platform developers that provide platform as a service, and there are also developers here, but they make platform. And these guys also pay money down to developers of infrastructure, and they use the infrastructure as a service. And the consumption goes up and the money goes down. The usage, infrastructure as a service is used by platform developers, and platform as a service is used by software developers, and software developers will create their software that is used by consumers. So consumers pay money, receive services, and at any point, if you decide that you're not just a consumer, but you become a software developer, in that case, you need to pay money to the platform developer to make your life easy. So you pay money. If you want to make life not so easy, then you can design your own platform, and then you pay money to these guys, because you don't have to spend money on platform because you made it yourself. So
Nilesh?
Yes.
Yeah. So a quick definition of the platform is a hardware running a certain OS with applications on it.
I think we should call out this definition and read it. So let's read it. Platform as a service. What does that do? So the definition says the capability provided to the consumer is to deploy on the cloud infrastructure. It's kind of very cryptic language. That's why I don't like the definition, but who am I to question them, the authority, right? So we'll not question, but we'll just attempt to read what they're trying to say, and then we'll infer it. So the definition language is very, very cryptic, and I dislike it, but whatever, let's read. So reading that, it says platform as a service, the meaning behind it is the language is the capability provided to the consumer is to deploy onto the cloud infrastructure consumer created or acquired applications. So you're basically taking some application, the consumer is taking an application created using programming language, libraries, services, tools provided by the provider, supported by the provider, and the consumer does not manage or control the underlying infrastructure. That's the key. That's kind of this definition means. Let's go elaborate on what that is trying to say in simple language. What they're saying is this consumer, the word they use consumer, is actually applies to this guy, not this guy, but the software developer consumer who is spending money on using a platform is using language and tools supported by the platform vendor, and does not get to decide how the infrastructure is constructed. They rely on the platform, they use the platform, they pay money to the platform developers, and they use their platform as it is designed. They don't get to question how the infrastructure is.
How about the OS? Do they get to decide what OS they're going to use?
Yes and no. Yes and no. I'll tell you how. Let's go with a simple example. So here we go to a famous platform as a service example. It's a very well-known platform as a service, and we will go read about it. So at the very simple level, if you see these three things: deploy, manage, and scale, you see the three circles. That's what a software developer will do. They'll create the application, they'll deploy it. So you write the code in your language, you deploy it, meaning you just give it to Heroku. That's what deploy means. You take your software, throw it at Heroku. That's what deploy basically means. I take my software package, throw it. I'm done. You worry about running it, managing it, do whatever else. So I want to scale it now. I can make it big, make it small by paying you more money. That's all I care about. I pay you money, you make it big. I don't have to worry about how to configure resources and all that, because that is your problem, platform developer, not my problem. I am the software developer. I develop the software, the light bulb on the left side, there's a light bulb in the laptop. That's my application. I develop the application, then I throw it at you. You deploy, you manage, you scale. I just pay you money. And then my end user customer will use it here. Now, if you just unwrap the cover under the hood, that's what it goes on under the hood. You have to have all these nut job things. The crazy amount of detail needed to make it happen, to be able to deploy, manage, and scale. You need to have an ability to learn and operate like these things. And we will actually do these things in our program. We'll do these details, but from a top level perspective, software developer will worry about creating an app, throwing it at the platform, and done. And we will do that exercise as well. In fact, there is one in our technology segment. If you scroll down somewhere, there is a platform as a service Heroku hands-on example. So we'll do this exercise later on. So we'll take an application, we'll create one, throw it at Heroku, and they'll run it. And we'll see it scale, and we'll pay them some money, or maybe not. But we'll decide that later. So that's what a platform developer will have to use this complexity and simplify it for the software developer. So a platform developer has a crazy job. A software developer has a relatively simple job: to pay money and use the platform. And that's how I think about it.
So that platform service is what software developers used to have to do, but now it's just been abstracted out and made into a service.
Yes and no. No, in the sense that certain companies don't like to go that simple route. They want to build all of this themselves. In that case, they are not only software developers, they are also platform developers for their own platform. They create their own platform themselves. In that case, they are dealing with complexity. Simpler applications are easy to deploy like this. If you're a big company like Boeing or Netflix, you will create your own platform and just use the underlying infrastructure.
A lot of these tools came up from companies that do that, like Kubernetes.
Yes.
Google's technology that they developed.
Correct. So that is true. And in fact, you will find us playing with this complexity more, and not so much of this simplistic view of the world. We'll just take an application, throw at it. We'll of course do this example as well, but we'll deal with complex things so that we really understand what it takes to build out a platform, to build out a service, so that our developers can then deploy their service on our platforms or our infrastructure as such. We in this bootcamp are not going to become developers, as we know already, but we will understand how do we use cloud technology to make the life of our developers easy. So in our companies, if you will, create a platform where developers can just throw the application, and be done with it.
So, like the old style of compiling code for Windows or for Linux or for Mac, that's kind of not even thought about anymore. You just, whatever your tool is going to be, you can put it on any OS. You can compile it on any OS nowadays.
So there are two types of languages. One type is the compiled languages. The other types of languages are not compiled languages, and I'll tell you the differences. Let's go see. Here are some languages that you see here. The languages mentioned on top: Node and Ruby and Java and PHP and Python and Go. All of these languages that you see here are not compiled languages, They just create an app and you throw it and it runs, because they are, there is a, what I call, the runtime provided by a framework that runs these languages that make things happen. Technically,
like the virtual machine.
Yes, technically they are slower. They are technically slower compared to your compiled code that you see if you write in, say, C or C++ and you compile the binary. And then it becomes an executable. Then you execute it. That program runs a whole lot faster than these non-compiled languages. However, most cloud applications these days use these languages. They don't typically use C, which is a compiled language, as an example. There are certain cases where you can run C as well. However, in the Heroku platform as a service, C language is not supported. Otherwise, you will see a listing. It is not listed. And so going back to the definition, it has to be supported by the provider. And in this case, C is not. So just remember that C is not supported by Heroku. Fine. Heroku doesn't want to support. That's okay. But as long as they support, and as long as you are using the language and tools that they support, you can literally take an app and throw at it and expect it to work. And expect to pay them $33 per dyno. And that's the pricing, but I will discuss pricing later. So you pay them money as you grow. You want more machines, you pay them more money, and they'll grow it for you. And you want to shrink, they'll shrink it for you. And all of this shrinking and growing is completely programmed. You can actually scale. Let's see if we can show you a scaling picture. So there's a quick video. See, these guys are scaling something, and you can literally move the counter from 1 to 2 to 3, and it will scale. We'll do hands-on exercise as well. I'm skipping this because watching a video is boring. So I'm skipping that. But we'll do actual hands-on where we will scale it ourselves and we'll see it happen. And that's what is needed to, when you are ready to pay more, they will scale it for you. And that's the idea behind a platform as a service. It is easy to consume. It is expensive. And for larger companies, it is, most companies end up creating their own platform themselves by using the underlying infrastructure. So meaning large companies will skip renting a platform as a service. Instead, they will develop their own platform because they have not only the software developers, but also have platform developers. And these guys together form a team and then just use the underlying infrastructure resource from infrastructure as a service providers, just like we saw the Vultr Cloud or the DigitalOcean Cloud or the Amazon EC2 Cloud or Azure VM Cloud, or goes on. It's a long list. So these are the infrastructure providers. We'll use them to build our own platform, and we give our own platform to our own developers, and our developers will throw their application on our own platform, and our platform is expected to scale. And yes, we will do exercises to make that happen. But those software developers in our company will expect that the company provided platform is able to just receive the application that the developers throw at us, and that our internal platform will scale comfortably on demand. And the developer team or the developer division in our company will pay internal funny money to us. You know what funny money is? When companies, one division pays the other division, the funny money transaction, internal transaction. That's what happens in most situations where a internal software developer team using a platform inbuilt built within the company will pay internal money to the other team and consume the resources provided by that team. Like a typical situation will be IT providing services to a team in the company, and the other team pays the IT department. That's the kind of transaction that happens. And so that's the kind of model that I'm describing. But bottom line goes like this. In a typical situation, you have a consumer that pays money to software as a service provider, that pays money to platform as a service provider, that pays money to infrastructure as a service provider. And these guys in turn pay money to hardware providers. And like that, it goes on. It's a long chain. The benefits flow upwards all the way. And so this is the person who actually uses it, the consumer, you and me. That's how the structure is defined in this service model discussion.
Could you say, Nilesh, that nowadays most developers use platform independent code? I mean, in general?
Yes, I would generally say that, but not necessary. I would say in cloud deployments, about 80 to 90% machines are running Linux OS, and the rest is mostly Windows. And so that doesn't mean that your applications actually are going a step away from the operating system type dependency, so they can potentially run on Windows as well. A classic example that I will have lots of exercises on is this thing called WordPress. You may have heard of it. This thing is a open source product available here. And this thing is called WordPress.org. Don't confuse it with WordPress.com. WordPress.com is a software as a service. WordPress.org is the software. The difference is this org is the software. You can download the software like that. Click that button. Whereas this thing is a service running the WordPress software. So two different things. This WordPress.com is not free. There is a pricing button. And you can choose a free price, but there are some limitations. But this is a service. This is the open source product, WordPress.org. It has a version available for you to download and consume. It has certain requirements. And you see the requirement set, it doesn't even mention whether it is Windows or Mac or Linux. It says you need to have a language, that is this language. You need to have a database, which is this database or this database. And you need HTTPS support. That's it. They're not even saying what operating system you need, because it's not really relevant. What they care about is you have these things. You have to have a database, either MySQL database or MariaDB. You have to have the language PHP version 7 or greater, and HTTPS support, and that's really it. They don't care whether it runs on Windows or Mac or Linux. So it's a step away from that. That's what makes it independent. And honestly, as a consequence, what happens is most companies tend to go towards Linux because it is cheaper. You don't have to have the Windows license cost. And it runs comfortably because most of the testing that is happening is already happening on Linux. So that's the reason why you see a lot of dominant forces, especially in the open source world. People are using Linux, and you will see go to any cloud, you will see Linux examples up front. Windows examples will exist, and some clouds don't even provide Windows examples. Like for example, this company, DigitalOcean, doesn't have a Windows option. They don't even bother. They give you Linux, and let me log in and confirm that. I think they don't have a Windows option because they don't care. So you create a droplet, and you click the create button, and you will not receive a Windows choice because they don't care.
Yeah, I think they'll let you do a custom image, but yeah, they don't provide it.
Yeah, true. I don't readily see the custom image choice either. Yeah.
Well, maybe it's not. Yeah, maybe not. It's not DigitalOcean, but some do.
Yeah, some do.
Okay.
Yeah, some do. Not these guys. So yeah, not everybody is a fan of Windows. So, but everybody is a fan of Linux. That's the thing to remember. So back to answering your question, can the application run on any OS? Pretty much these days. Most of the applications are a step away from the OS, so they run. But a large majority of them tend to run on Linux, and more importantly, these days tend to run inside containers. And we have, by the way, revised our curriculum in the last 2 or 3 sessions ago to go exclusively into containers more and more and less into VMs. And we'll at appropriate time switch over our discussions to using container technology as opposed to virtual machine technology. And I just want to quickly check a quick poll on how many of you are new to the concept of a VM or a virtual machine. Just want to quickly check. If you're new to it, if you used it, I just need to know. So I can then adjust my discussion according to what a VM is. So a VM, sorry, not this. No, not this. VM is something that runs like this. So you have a machine here called Cloud Genius. This machine has a base memory of 2048 and a boot order and a video memory and some disk associated and an operating system loaded. So that's the setting that you can see in this machine. Has a system with 2048 MB RAM and a processor dedicated to it, and some storage allocated to it, audio cards, network gear, things of that nature. And if you start it, it starts a Linux machine. It is starting up right now. And that's what you're looking at as it starts. I'll bring it up. On the other hand, it is running on this real machine, which happens to be this Mac OS, which has a 16 GB memory, whereas this machine has only 2048 MB memory. So that's the concept of a virtual machine. The question I have is, if you're new to the concept of a VM, I need to know. So I can adjust. If you have used VMs, just raise your hand or say yes. So I'll adjust that accordingly. I can see 2 or 3 hands. Okay. So I'll adjust. The idea here that you see is this VM running Linux is running on top of the physical machine that I have here, which is the Macintosh. This machine you're looking at is not a physical machine. It is a virtual machine. This is the Cloud Genius workstation, by the way, the OVA file that you're downloading right now. This is the machine. Its password is Cloud Genius. And I'm going to shut that machine down because I don't need it right now. And that is the idea of a virtual machine that you get when you go to a cloud provider, or give me an infrastructure, some kind of a resource. That's what they typically give you. And so the picture that you see here is kind of the underlying hardware. That is how these virtual machines are carved out and allocated to a person demanding those. And that's our brief on these service models that we just discussed: software as a service, platform as a service, and also infrastructure as a service. Out of the 3 things here, the platform piece is kind of difficult to understand and digest and not super clear. Most people are not clear about it. And I think this picture helps. Excuse me. This picture kind of helps you get a good perspective on what that platform really does. And big companies tend to develop their own platform.
In the NIST definition, they have just those 3 service models, but really now there's more than 3,
Yes.
database as a service,
Yes.
everything as a service. So
Yep.
How do we adjust the definition for that?
So yeah, honestly, I would suggest that you ignore the NIST definition
Okay.
and move on, because this definition is old. I mean, yeah, it's like government, right? They are slow, they will adopt and eventually update the definition, but you don't have to wait for it. You can move on with using your services and do your business.
Okay.
It's a definition. I mean, take it with a pinch of salt. Although they're a standards body, it is hard for them to catch up with the industry. So they lose sight and the definition becomes old and they call it a final definition, and it's back in like 2011. Come on. And
Oh.
so it's old. And so just leave it at that. I mean,
Okay.
I'm not going to revise the definition because I'm no authority. And the authority themselves are government. So I don't blame them. They're supposed to be like that, slow. So ignore them, move on. That's my take on it. Okay. And yes, you're right. There are other types of services, not just these three. Basically, these days, XYZ as a service, anything you can think of that you provide as a service, people are coming up with random names for their services, and sometimes they're interesting, sometimes they're boring. It's really up to us to decide what value we provide when you are a service provider, and who's the receiver of that value, and do they actually buy into that definition. That's what really boils down to. If I'm a service provider and I provide a service, is my customer digesting and buying into whatever I'm providing to them? And that is good enough for me. I don't have to strictly follow this old 2011 definition. That's how I read into this. I will use it as a guiding principle, but then leave it at that and move on. Okay, so now the next idea. Next idea is 4 deployment models. Here, 4 deployment models are public cloud, private cloud, hybrid cloud, community cloud. 4 models. Let's go quickly, either reading these or I'll let you read them yourself later on. What I'll do is I'll describe them in a picture. So in a picture, new sheet of paper coming up. And in there, I will define, here is our world. So this is the world. I was attempting to draw a circle. That's how my circle looks like. So it's the entire world. And so if I have a cloud here, and anybody in the world can use it, it's a public cloud. Simple. It's publicly accessible. Anybody can consume. An example of this would be Amazon Web Services. Simple example. Or DigitalOcean or Vultr or Azure or any of those big ones. Public cloud. Anybody on the planet, go use it. Unless you are North Korea, in which case you cannot even get out of your country. You cannot. But then nobody cares. So we just talk about the rest of the world. So the rest of the world, access to public cloud, fine. That's what a public cloud is. Now, what is a private cloud? Private cloud is basically something where I define my boundary. And this is my boundary. And so in that boundary, that is my private area. And so if I create a cloud here, anybody who is inside my boundary can access my private cloud. And that is how I define private cloud. It's very, very simple. If my boundary is really small and I am going to look at my company with 10 people and a small building where I have a bunch of machines, and I am going to programmatically allow them access to a shared pool of compute resources all within my company, like according to this definition, the 5 key characteristics. It is not going to be infinite, but it is going to be on-demand, self-service, broad network access, resource pooling, rapid elasticity, not infinite, limited, and measured service. And all these characteristics, if the characteristics are met, I can potentially construct a private cloud in my boundary, in my company, and give them all the 5 key characteristics. If they are met, I have a private cloud. It is limited to my boundary, not open to public, and therefore, as long as these 5 key characteristics are met, I get a private cloud. That's how I define private cloud. Now you will question, what is the difference between a data center in my company versus a private cloud in my company boundary? What's the difference? So here is a data center in my company, and this is also private. It's not private cloud, but it's a private data center. So what's the difference between a private data center and a private cloud?
Well, a private cloud could encompass many data centers.
Correct. Yes. Yes. You can have multiple data centers. You can.
Right.
Yep.
So private data center is.
So I have 3 data centers, and I will pull them together in one big data center, like one big data center. Okay. But I still have a data center. The real distinction between a data center or a collection of data centers and a private cloud. What's the distinction?
And a data center could contain many private clouds. So it goes that way too.
Yes, yes. But the real distinction between this and this are the 5 key characteristics. Meaning these things. Are you able to allow your users to create on-demand self-service? If your data center has a method in which you have to create a service ticket and have somebody provision a machine, you are not a cloud. It has to be programmatic and click a button and get a machine. That's what a cloud is. It's one of the characteristics. Click, get a machine. Don't have to make a phone call, don't have to create a service ticket, nothing. Don't have to get a manager approval. Just click, get it. That is what on-demand means. I want it, I got it. Next one, network access. I think it's a given. In a private company, everybody can have access to internal network. That's a given. But resource pooling, meaning resources are shared within the company. If your data center is limited to say this and this and this 3 data centers you have, this is allocated to marketing, this is allocated to your service operations, and this is your manufacturing operations. So you decided that this data center will belong to manufacturing, and this goes to marketing, and this goes to service providers or service operations. So then you are basically defeating one of the 5 key characteristics. You're saying it is not shared, it is not pooling. You have to share it across your divisions in your company and share them, so that the idea underlying is sometimes when you have a large pool of resource, sometimes the marketing demand will be heavy, and this is the marketing team using your cloud. And other times what will happen is that the marketing demand is only small and rest of it is taken and available for your service operations, customer service operations, because your product is now launched, marketing work is shrunk, and rest of it is available for service organization to use. And that's being able to flexibly share, grow among your stakeholders, even within your company, is something that you have to account for. And if you are accounting and allocating a dedicated data center for marketing and a dedicated data center for service, you are defeating the definition. So this data center is for marketing, and this data center is for service operations. Then it cannot grow and shrink. When, typically what happens if you launch a product, then the marketing consumption is high. After the product is launched successfully, the marketing consumption goes down, and after sales service goes up. And so you can potentially benefit from having a larger available resource by sharing these 2 together and dynamically allocating as and when people need. So your marketing guys need it right now, take a bigger portion. And then when you're done, you relinquish your resource, and it is better utilized if you go it this way as opposed to allocating it specifically, like dedicating a particular resource to a particular organization. If you are sharing and you are multi-tenant, you are better utilizing your resources. And that is another key characteristic that you have to understand, differences between a data center and a private cloud. Another one, elasticity. This is something that has to be understood, that your team members in the marketing side or service side or any other side should be able to grow and shrink the number of machines that they might need as they need, or shrink it back to a little number that may be sufficient as they go along over time. This shrinking and growing aspect is also a critical characteristic as defined in this rapid elasticity. And of course, they will pay for it as they go along. So these characteristics, if you don't meet them, it is a data center. It is not a private cloud. So to have a private cloud, like for example, some companies will deploy a bunch of hardware that might look something like this and not configure it to meet these characteristics called out here. Then they have a data center. They don't have a cloud. It becomes a cloud when you meet these characteristics. You have to enable on-demand self-service and share the resources across everybody in the private area, in the private company, in the domain, in the boundary, and bill them as they consume them and allow them to grow and shrink. These
Hey, Nilesh, what if I was to use a product like ZeroStack on top of my data center's resources? That would, check that out. That would do it, right?
Yes, correct. ZeroStack, I think, is it open source or not?
It's open source. Well, I think they're charging for it now already.
I don't think it is open source, but if not this, there is OpenStack, which is open source. There is other stacks. CloudStack is open source. So these tools are used. So this is exactly what needs to be installed on top of this kind of hardware. You throw this software on top of this hardware, and that will make it a private cloud. That's what Boeing has set up in your company right now. You can see it. You know it. Who's that? The people. Sami Turan, Kara South, Sami Turan. These guys can give you access to OpenStack. You should reach out to them in your company. Both of them, I think, are people who manage I don't exactly know what they do, but they were in a previous boot camp. You can talk to them. If you need introductions, I will connect you with them, and you ask them. They should give you access to your own company's resource. Your company has a large infrastructure like this running this OpenStack. Use it. You should use it. For those of you who are not in Boeing, I'll tell you how to use this. And I will begin with telling you, go to Facebook and open an account here called TriStack. And so it takes a couple of days for you to establish. But if you want to use OpenStack without being a Boeing employee, you go to this website, tristack.org, and log on to Facebook, and then join the Facebook group. After some days, somebody will approve it. And then you get access to OpenStack for free. Play with it. I'll tell you more about it later. I'll put this link in Slack chat. So there we go. I'll do it later, but we are recording this. I'll remind myself to send you a link. Tristack.org. Access it, join the Facebook group, and then you will eventually get approved in a couple of days. So you can play with OpenStack without having to have a lab for you. So it's just there for you. Okay, that is OpenStack. This is how you distinguish between a simple data center that is a bunch of machines that looks kind of sort of like this from a fully functional private cloud that actually meets these characteristics. That characteristics are the critical things to distinguish from a cloud and a data center. That's what really differentiates them. Okay, now Having said this, we discussed private cloud and we discussed public cloud briefly. Now, if you mix them together, it becomes a hybrid cloud. Very, very simple. And what's the usage scenario? Why would I mix? If I am Amazon.com, not Amazon Web Services, just saying Amazon.com, I sell stuff. I mean, I am this company, for example, and I sell stuff. And I buy these shaving brushes and, whatever, iPhones, whatever, these things. So that's what I sell, and I have a store. And I need a website to make me sell these things. So I need a large scale operation to have this thing available and being sold on a bunch of machines sitting somewhere in my company. So I can use a cloud. I can use my private cloud because I'm a gigantic company and I have to sell these iPhones and shaving brushes. So I'll set up that one in my private area. Now what happens is day after Thanksgiving is coming. And so now what do? I need to grow immediately, but I don't have enough money or enough capacity in my buildings to fit in another large number of hitting customers who's going to hit my website and bring it down, literally. So I need to scale out, scale big. So what do? I go to the public cloud. In addition to using my current private cloud, which can be not infinite. It is small. So I will expand my product set, my applications, grow them into the public cloud come Thanksgiving or day after Thanksgiving. And I'll keep running it like that until December timeframe. And after December, the returns period comes in, and then the traffic kind of goes down a little bit. And at that time, I will let go of the public cloud and come back to my private cloud and keep using just the private cloud. But in peak times, I'm using both private and public together because my applications are written in a fashion that it can run not only in my private cloud, but also in the public cloud. So if this is the timeline, and this is January, February, March, April, May, June, July, August, September, October, November, December. If these are the months, so in this time frame, I need an extra data center. I have my data center that I'm using, but that is falling short in these months. So I need to extend my capacity. I need a bigger data center immediately on the fly, on demand. So I go to the public cloud. This portion is public. Rest of the year, I can do my business in normal private cloud. When I need more CPU, more horsepower, more resources, I expand into the public cloud. Breathe into, sometimes this is called bursting. Burst into public cloud. So when I need more capacity, I just burst into the public cloud. When I'm done with it, I just shrink back. That is what is a hybrid cloud. There is another way to define this idea of a hybrid cloud, even though it is not covered by this definition. And that is that sometimes people have come up with the idea of mixing and matching two public clouds together. And that is also hybrid, even though this definition doesn't allow that, but who cares? So hybrid can mean whatever you want it to be, although they are saying it's a composition of two or more distinct cloud infrastructures, private or community or public, that remain unique entities but are bound together by standardized proprietary technology that enables data and portability. Basically, it means my application can run on the private as well as public cloud. So if it can run everywhere and I want more resource, I can just get some resource from the public cloud. Now comes the fourth one, community cloud. And this, okay, hold on. Yeah, this community cloud definition is basically a subset. So if you go back to my Venn diagram, let's go draw the Venn diagram again. And I'll draw it simpler. So if this is the world, and this is my private company, and this is my private cloud. So anybody in the company can use the private cloud. If this is the public cloud, anybody in the world can use public cloud. And sometimes there are other companies or other institutions or other people or other individuals or other entities, I would say, clubbed together to form a group or a consortium or a community. So I have this person 1, person 2, person 3. 3 people form together a community and they create their own community cloud. So this will be the community cloud used by these 3 types of people. And that's the generic definition of what this claims to be. Community cloud is. Think of it as a cloud for the government agencies. So all the government agencies forming together to use the government cloud can become a community cloud for the government community. So it has to be a specific community of users that belong to certain organizations that have shared concerns, like US government entities. They all club together and share the government cloud. Another example is, I think with government cloud, you can possibly see that Amazon has given a government region. So in Amazon login, you will find there are multiple locations, and one of them, which is not visible to me, is the government cloud. And that is the cloud which is dedicated to government people. And I'm not a government officer, so I don't see it. But I know it's there because I have seen it. So that's a definition example of the community cloud. So now recapping our definition discussion. In this definition, you can read more about it. It's basically on-demand self-service ubiquitous access of resources available in a shared fashion that you can grow and shrink as you need. You pay for it. You can use it as software as a service, platform as a service, infrastructure as a service, put that in a public cloud, private cloud, community cloud, or use it in a hybrid model. That's their definition of cloud computing. And I think it's a generally okay definition. I don't dislike it too much, except that it is kind of hard to read. But that's what it is. So just live with it. All of us are already living with it. So yeah, we cannot fix it. If we can, we would become government officers. So we are not there. I don't want to go there. I used to be one. So this is definition. I'm going to paste. You can search it. This link should be available. And it should also be available somewhere here. I think I have mentioned it somewhere here. So what I think I covered today up until now is this thing, this formal definition portion. This is what is written down here already. So you can read it, refer to it, and watch it. There are some short videos and read some reading material. So you should be able to go through that on your own. Don't do it right now. So back to technologies. What I want to do right now is take a short break and then jump onto the idea of understanding virtualization as a technology. And we'll go deeper into it. And then we'll switch onto other topics as we progress. We will take a short break and I will start a timer. And here goes the timer. It has started. And I will now walk away from the computer. I will come back at this time before the time finishes, and we'll resume our discussion. If you have a question, you can always ask because my microphone is open. My camera is also open. I'm just walking away for a minute and I'll come back. I'm here. But it's a time that I want to give you to be able to breathe and do whatever you like.
You have a set time?
And you can ask questions if you like.
Nilesh?
Hello.
Hey there. So when I went out to Slack to reset my password,
Uh-huh.
it said that it doesn't have an account for that workspace yet.
Can you tell me what was the login name, email address that you used?
Tammy R. Bates at G.
Got it, got it. So I'll create an account for you.
Okay.
Let's go to that. So chat dot here and Bates.com.
Yeah.
And then I invite you. So now you have an email.
Okay.
Please check that email and you can create one.
Okay. Thank you.
You're welcome.
I'll work on my cat face next. I don't, like I said, it's not even really my laptop, it's my daughter's.
Yeah.
So, kind of figuring out what's what.
She can fix it for you. I guess you, Mukesh is your friend, right?
Mukesh Shahi, yeah.
Yes. Yeah.
And Rebecca Anderson, she took your class. She said she loved it.
Both of them did.
And Brad Scheffbauer.
Yes.
So I knew, and then there was, I think his name was Justin. He was the one that helped me get registered. But like I said, I heard nothing but great things about the class, so I was really looking forward to it.
Thank you. Thank you. I try to not bore you. That's my goal.
Oh, definitely not boring.
Because if I bore people, people will not come and join the program. That is my primary goal, is to not bore people. Second goal is to make sure that you succeed in whatever you want to do.
Yeah, well, it's a lot of information.
Yeah, we just first day, halfway through, you know.
Yeah.
And the thing you will notice is that I don't have a PowerPoint to flow through. You know, most programs, most classes you will see will have a PowerPoint deck that the instructor will go through. Okay, slide number 1, and they'll read the slide and bore everybody to death. Oh my God! Yeah, I hate that. I cannot stand it. My challenge is to make you sit here listening, interested in whatever we are doing for 72 hours. That's my challenge. It becomes hard. I try that.
Yeah.
Yeah, 72 hours is a long time to keep you entertained and interested and doing. It is hard, but I try.
Well, I know Rebecca said, because she does mostly database work, and she just absolutely raved it and said it was a great class, really held her interest. So.
Yeah, Rebecca, she and I talked, I think, on the Eclipse day. She went down to somewhere in Oregon. She saw the eclipse herself.
Oh.
Full eclipse, I mean, 100%, what's called totality.
Yes.
I was able to see 96 or some percent here. I did not travel.
Same here.
Yeah. I think 93 or whatever percent we saw was good enough for me. I couldn't handle all that driving.
Well, the driving and the traffic and the people. And
It's too much. Yeah, it reminded me of India, and so I avoided that.
Yeah, I don't blame you.
Yeah. So I guess we have only 2 people right now.
Elise,
Where is everybody else?
Elise, can you hear me?
Hey, Chris joined. Is Chris here?
Yeah, I'm here. Can you hear me?
Yes, I can. And so I would suggest that you open up your camera if you have one.
Well, I'd have to move over to my laptop. I'm just on my desktop right now. I don't have a camera here.
Okay, no worries. Next time we'll grab
I'll
one.
move over to my I'll move over there. Yeah.
Okay. So we have maybe a quick round of intro will be nice, right? We don't, not everybody knows everybody else. So we have one more person I'm expecting. So right now in this group, why don't we just do a quick round of introductions? We haven't done it yet. I should have started with that, but I didn't bother. Sorry about that. So let me begin. My name is Nilesh. I created Cloud Genius about 4 years ago. I have been running this program. Let me shut this timer off. So I've been running this boot camp. Primarily, we run it 3 times a year, January, April, May, and September. So this is the third one. That's what I do. I build new content the rest of the year. I enjoy building, working, practicing, and I consult with companies like Boeing, like GE Capital, big strategy projects on top level things. And I come from a company called Microsoft. I worked there for 10 plus years building a thing that you use today. It is called Skype for Business. It used to be called Link. It used to be called Office Communicator before that. And before that, it did not have a name. And the thing that you see is this thing called Link. Let me show you a picture of what I'm talking about. So the product Link looks like, or Skype for Business looks like this. You use it. I don't have it. But yeah, these red color symbols that you see here, they show that people are in meeting. And sometimes they turn green. That means they are available. Sometimes people can become busy on a phone, in a meeting, or away, or appear away. So this idea is called presence detection and physical presence expression. So this is the underlying technology on which I have a patent. And that's where this thing comes from. So detection of physical presence. If you can search on a patent database, you can find my patent there. This I did in 2004 timeframe, and now it is 2017. So that is me in a nutshell. I come from Indian government in this country for the last 20 years, and I am now a US citizen. I call myself a Sammamish Indian. That was a joke. Okay. I cannot actually crack that joke anymore because I'm not an Indian anymore. I'm a US citizen, so I call myself Indian American as opposed to American Indian. But okay, moving on. Let's see on the list. We have Chris. Hey, Chris.
Howdy. So, I'm from Microsoft as well. I was part of the team that built the underlying infrastructure of Azure. I'm now at IBM as a contractor for my own company as an infrastructure architect for Bluemix.
Awesome. Good to hear about you. By the way, Chris has done part of the bootcamp already. So he's doing the remaining part right now. And he might want to continue and finish off. I think he could not have enough time the last time. So he wants to catch up on the missing elements. And I welcome that, Chris. So thank you, Chris. The next person on the list we have is Mark Drees.
Yes. Hey, I'm a system integrator, formerly SA, and we maintain the health for a set of Boeing servers, and I'm a co-worker with Tammy Bates.
Oh, hi. Good to know. And so next one we have James Wickline. James is a former Navy officer and a former Boeing person. Right, James? James will describe better.
Can you hear me?
Yes, I can barely hear you, but I can.
Okay, I was laid off from Boeing, so I'm taking Cloud Genius. I'm using Washington State Trade Act resources to learn a new career. So this was part of that. I was
Thank you, James.
a system engineer at Boeing a year ago.
Wow. And James is, he used to be a Navy officer a long time ago, I think. I don't know how long, but yeah, he was there. So thank you, James.
Sure.
Next on the list we have is Carrie. Hi, Carrie. You're muted. Let me unmute you.
Hi.
Yep. Hi.
I'm Carrie Gammon. I work for Boeing. I'm an architect in what's now called Boeing Global Services. Those are aftermarket services that Boeing supplies to all the airlines, both commercial and military now.
Wow.
And I do overarching architecture, kind of system of system architecture. I've done I've been at Boeing a long time, so I've worked all over Boeing and corporate and finance and everywhere else. And I've actually met with Nellish another time because I helped to stand up kind of an intro to cloud that actually covered many of the things that we went over today, but yours had more interesting examples than what we had. So,
thank you. My examples are live, and they are real time, and I hope they are interesting. I don't know. You tell me. And so thank you for saying that. And thank you for introducing yourself. Next on the list we have is Tammy. Hi, Tammy.
Hi, I'm Tammy, and I work for the Boeing Company, and was a system administrator for several years, and now do more of a system integration type job. Primarily been supporting HPUX for several years, so just now starting to learn. I've built some VMs, so I'm familiar with VM technology, but wanted to get more familiar with the cloud. So.
Sweet deal. And Tammy has been taken over by a cat.
I have.
That's tripping me out. I want one, but I want a dog.
I don't even. Well, I saw they had an alien. I don't even know how it happened. But I think it's funny how the mouth moves when I talk.
I
know because what they are doing is substituting. It is actually beautiful. It's a good piece of software. I think Tammy's daughter has taken over control of her laptop. It's actually her laptop. She's using it right now. So yeah, that's a fancy feature actually. And it's a feature of your camera software. And so there should be a button somewhere to change and swap faces to make a funny looking person, or I don't know what, but yeah, lots of pieces. Lots of options.
I'll work on that when I get a chance.
Yeah, makes sense. No worries. So let's see. Next person on the list we have is Travis. Hey, Travis.
Hi. Yeah. What used to be a virus is now a feature, right? You know, little talking face in front of yours.
I know.
Yeah. Hi, I'm Travis. I worked at Boeing for about 11 years. I came to the Northwest with the Navy years ago, and spent some time doing customer service, service engineering, documentation, and even got a little stint with field service and flight test before last year's layoff happened. Now I'm looking at re-gearing myself towards something in the technology sector, which is just hot right now around here. And you know, I'd like to take some of my business experience and see where I can take that. Maybe work for a company that's really fun to work for. Sorry if that hurts anybody's feelings.
Yep, and that is awesome to hear. And thank you for your introduction. As Travis is also a Navy person, I think he mentioned that. So that's great that we have two veterans. I have a special interest in helping out veterans, and so
Three.
Sorry. Oh, yeah.
I'm a veteran too.
I forgot. Chris is also a soldier. Yes. I forgot. So sorry about that. And so, yeah, there we have three, veterans here. That is so awesome. So awesome. Just, I think, a long time ago, 4 years ago, when I started this Cloud Genius thing, I got an honor to serve our soldiers coming home, to train soldiers getting civilian jobs, and that was my first boot camp. It was a custom-made program just for soldiers at the Joint Base Lewis-McChord. That's how I started the company, with this military contract, and that was an honor. And that was beautiful, by the way, that I was able to beat Microsoft and Amazon at a contract with the US military to train soldiers with one guy at that time in my company. That was amazing. But that was the best program I ever ran for a group of people. I'm not saying, I just love them. That was a different group that my exposure to, soldiers, like fresh off the military base, like coming out, that group is so much dedicated, motivated, you would never believe. I mean, if some of you who have seen that understand it, but if you haven't seen it, you will never. I never understood what I am dealing with. It is a mind-blowing experience to deal with fresh soldiers. I never had that opportunity, so I still have that in my mind, and that is just amazing, and I love that. So I do that special program just for soldiers late and occasionally, but most of the time I run a program just like this, and We'll do the next one sometime for soldiers. So thank you. Let's go switch back to our topic and continue our discussion. I want to now describe to you briefly about the underlying technologies that constitute these resources that we talk about, right? We talked about underlying resources, right? Compute, storage, and network. So let's go see clearly what they mean by in this definition. They mention about these resources, right? Let's go see that definition again. And they mention here shared pool of compute resources. Somewhere there they'll say that. And they'll define what they mean by resources. So they mention configurable compute resource. That's the word right there. So they have networks, storage, server, application, services. And we go into these details step by step, but understanding what these things actually mean. So new sheet of paper and describe to ourselves what those key components that generally constitute these resources are. There are three basic things. They go hand in hand, pretty much like this. And so generally speaking, they are compute, storage, and network capabilities. So practically speaking, if you look at a computer like this one, in this machine, you have some CPU. Let's go see how much we have. Does it show how much CPU do you have? It doesn't show that. Oh, there is 2.8 gigahertz Intel Core i7. If I look at my activity monitor, I see that I have some CPU consumption going right now. It is showing me, excuse me. Yeah, it is showing me that I'm using 109% on Zoom conference and 54% on Windows Server and some kernel task and some other CPU consumption. OneNote is consuming 0.4% CPU. So that's how the CPU is getting allocated. How much CPU do I actually have? I think I have, so this whatever I like machine is dead. So this command should go away. So I'm going to kill that one and then focus on this local machine where I have an access to the terminal, where I see that I have 8 virtual CPUs. As you can see that it is showing you at the very top, 1, 2, 3, 4, and then 5, 6, 7, 8. 8 virtual CPUs showing activity of various things happening as we use this machine. So that's the compute resource. It is actually coming from the chip under the hood made by Intel Core i7, that chip that you can see here that you can buy from Newegg. That's the CPU that is inside the machine that is giving me the horsepower needed to run this laptop or the other desktop.
Hey, Nilesh.
Yes.
Quick question. How did you have over 100% utilization? Does that mean you scaled since you turned it on or something? Or
no, these are 8 cores, so they go up to 800%.
Oh, I see what you're saying. Gotcha.
Yeah, there are 8 cores in here. 1, 2, 3, 4, 5, 6, 7, 8. So now this is the underlying CPU resource. So we have to have a resource that you can then share with other things, right? Similar to that, there is this other thing that I mentioned, which is storage resource, right? This storage resource, you have to have some storage here. Let's go see how much storage I got. So in my storage machine, I have some disk available, 751 gigabytes for the hard disk called Pro, and another 209 megabytes for, oh sorry, no, this is 200 MB for a Linux partition. On this Macintosh, there is a partition that runs Linux. And so that is what that partition is showing up in 2 parts. The main hard disk is allocated, most of it, to the Macintosh OS on this MacBook Pro, but 200 MB or so is allocated to Linux machine, Linux OS running on the same hard disk. It is not running right now, but it can. If I reboot into Linux, it will go to Linux on this exact hardware. So this is the storage element of the resource available on this laptop. Let's also see the network capabilities available on the same machine. If you go to the network section, you will find I have a Wi-Fi card and I have a Bluetooth connector which is not connected. I can also additionally add more Thunderbolt bridges or other types of VPN connections, and these will establish a method of connecting resources together. So the network resource is basically a connection resource. It helps you connect things to other things. A compute resource will help you compute, and a storage resource will help you store stuff. Now you will say, what about RAM? And also, what about GPU? And what about other things? So where do they belong? And so you can generally call RAM as a storage thing, but not really. You don't store stuff. You use it as a transient temporary place. So it is actually a distinctly different thing, not a storage element. And GPU is also used for computation. So you can put this in this bucket, but not really, because GPU is actually dedicated. So yes, it is used for computation. And yes, it is available in this machine as well for display. I have a 1536 MB of display graphics memory, and that GPU is available in the system report. You can read about it, and you can see that the hardware resource has a graphics card. Where is that card? It's hiding somewhere.
Is that also a service, Nilesh? Parallel processing versus serial? So GPU is parallel.
Say it again. Ask your question again, please.
Is that available as a service, parallel processing through GPU? I guess just like coin contracts, but I've never seen anybody have that as a service.
Let me describe to you. This GPU can also be used for computation. It can be. And I'll tell you which types of computations happen on the GPU better than it can happen on the CPU. I'll describe those scenarios. First of all, let's go understand what a GPU is. If you go buy an NVIDIA card, a graphics card, that looks like this. You've seen graphics cards that go inside your machine, and then they give you a video memory and a place to connect your monitor. And that is a GPU. It's graphical processing unit. It does special mathematics to do pixel shading to make your images and animated videos look better. That mathematics is specifically designed to run on the GPU, the graphical processing unit, which is inside this thing. It is made by NVIDIA and AMD and other people, and it looks like this. Or other examples. You can have multiples of them, and sometimes this kind of GPU unit is specifically useful for one mathematical computation known as Bitcoin mining. Yeah, so cryptographic currency, which is also known as Bitcoin, is typically very efficiently calculated. The math behind it is efficiently done in a GPU. That is where GPU is tremendously useful. And let's go see where it's applied to cloud. How does a GPU apply to the cloud setup? I cannot even connect my monitor to the cloud. Where the heck this GPU comes into play? That's what I want to understand. So let's go figure it out. I cannot connect a monitor to my cloud machine, but I want to use GPU for what? Let's go see that. So I'm going to sign on to our Amazon console, because Amazon does provide us machines that has GPU, and you can choose that. So I launch an instance, and I'll say I want to get some Ubuntu server, and I will say I need some here are the guys. GPU graphics. You can see that it is providing you extra GPU horsepower in addition to CPU horsepower for high memory, mathematical computing, graphical intensive computing, workstation modeling, 3D rendering, video rendering, fluent application for your aerodynamic wing design for Boeing airplanes, ANSYS, or what's that thing, German French company, Dassault Systems, will design your airplane design models. They will need that kind of a graphical horsepower to make your plane designs efficiently done, to have the least amount of drag as it flies through the atmosphere. So that kind of computational horsepower is needed, which is supported by, most efficiently done by a GPU. That is this unit. So you have to get either this machine or this machine or this or this or these guys, the GPU instances. Those are dedicated GPU machines available in Amazon Cloud for the purpose mentioned right here. You can also use these machines to do Bitcoin mining, meaning you make money. And yes, you can, provided you get the underlying GPU machine for a cheap price. You can actually make some buck, or maybe $2, maybe sometimes more. If you are able to get a cheap machine at a low price and you do your computation and you generate a Bitcoin could be like $1,000, and you might spend $400 on the GPU machine, you might make some money. And that might happen.
$4,000 right now.
Is it 4,000?
4,000.
Wow.
Yeah, Ethereum you can mine now, but you couldn't even make anything on any of these for Bitcoin.
Wow.
Believe,
So
yes,
so
sir.
what happens? I know. Yeah. So yeah, the price is so fluctuating that I think the last time I saw it was like $1,000. So it's $4,238, and that's the price of a Bitcoin. It's just one coin, this much. And so to mine a coin, it requires a lot of computational mathematics, and you have to run a program which is called a miner software. You have to run the software to do number crunching and to calculate the hash needed to claim a coin. And then you get the coin. You put that coin in your wallet, or you can sell it to get $4,238.99. Or you can spend $1 or get a coin. Either way, the market price. But when the coin prices go high, people tend to mine more. And when people mine more, they need more machines like this. And so what happens when you go get more machines like this, that Amazon will rack up the price as more people want these machines. So effectively, you don't make too much money. You make some money. So the best way to make money is actually stealing. And that's what hackers do. They steal your computer and Bitcoin mine on it and make money on your computer. That's the most efficient way to generate Bitcoin cash, is to steal other people's computer and make Bitcoin. That's what hackers primarily, that's how they make money most of the time. There are other ways to make money illegally, but legally, if you want to make money using these technologies, it is not efficient, because as more people want to make money using Bitcoin and you want to use these resources in the cloud, the pricing of these resources will go up, as Amazon will take more money from you and make these machines expensive. And as a consequence, there is little or less interest in mining Bitcoin using GPU. So that's a brief discussion on GPU side. Let's go back here. These things, you can actually expand it to include GPU and RAM and other capabilities on a machine level. Now, if you look at another cloud provider, I'll just show you one more, and I need to log in there. It's called Rackspace. And I'll just log in there and log in. And the reason I'm going here is to show you a specific user interface that these guys have developed. And I actually like that. That's why I'm going there. I need to get a verification code, which will be sent to me by SMS. So I'm waiting for the SMS to arrive, and then I will log in. And once I log in, I should be able to show you these characteristics. So the SMS has arrived, and here it is. And I will grab the code and put in right there, and then go in. And here in this Rackspace cloud, I will attempt to create a new machine. And I will go to the Rackspace server creation, cloud server creation, and look at the user interface, which I find it interesting to explain to you. So when I say create a server, it shows me exactly what I was describing to you and I had in my mind. So I'm going to choose a Debian Linux, and there I will choose how much hardware resource I want to add. So I'm basically talking about creating a shared pool of compute resources. So here, if you look at this little picture here, that will help us understand much better. So as you look at this blue colored shape that you have, it has these 5 characteristics: vCPU, RAM, disk IO, network, and disk. Those 5 characteristics that we just discussed briefly on my handwritten note, you will see that this blue bubble thingy will change its shape as I increase the compute horsepower. So if I want to add more computation, you see what's going on. It bumped the height of this bubble towards the CPU section. It increased the shape of that, whatever that thing is. Now, if I adjust the memory portion, you will see that the RAM grows. And also you saw that network grew along with it. You will also see that IO is also in your control. This IO is basically the speed of the disk, how speedy or fast or how slow disk you want. You can get a big, fat, slow disk, or you can get a small, fast disk, depending on what your usage is. If you can get a fat disk which is slow for cheap, you can. But that gives you more GB, doesn't make it efficient. It is still a slow IO per second. So you want to get a high performing disk, that's what you have to pay for. So this is the kind of storage characteristic that I want to expand and make sure that you get this idea clear, is that these resources that we are talking about, storage, compute, and network, have another level of depth behind it. And that's what I want to highlight to you. So another sheet of paper. In case of CPU, you can get more or less, and that will compute and adjust the amount of CPU you want. You can get higher megahertz, higher gigahertz CPU that go faster and slower, and that will affect the performance of your application. And that's how you need to worry about when you're sizing something, how big the CPU should be and how many of them. That's one thing to remember. And the speed of it. Is it a fast CPU or a slow CPU? And how many of them do you need? And you can increase or decrease accordingly. Similarly, same thing applies to GPU. The purpose here is slightly different. The mathematics underlying is different, but you can have any number of GPUs as you like, and you can grow or shrink them. And here, the calculation metric is not this, but flops, the floating point operations per second. How many floating point operations per second can you compute on the GPU resource that you want to get? Similarly, the next resource in mind is random access memory. And you can obtain this in terms of how many GBs you want. Sometimes you want half a GB. So 512 MB RAM is good enough for a very small application, versus larger machines will have larger RAM. And that's one way to think about. But also remember, RAM can be fast or slow. And you can see that in how the machine performs and responds to request for random access memory on a given application. So fast RAM usually have a low response time. And a slow RAM, of course, has has a long response time or long response time. So that's a problem. Sometimes some cloud providers will give you slow RAMs because they are cheap. Fast RAM is expensive. And so you have to basically pay for all these resources as you go along, and it is shaped up in form of the overall price of the machine that you get. And you can see some of that right here. If you go to Vultr Cloud and try to configure a machine with 1 GB memory in Seattle, and we go select Debian and say, I want 1 GB memory, and I get 1 CPU, and I pay $5. Good. Next, compare the same thing with DigitalOcean. And I'm going to log in. Okay, come on, log in, please. Log in. And here I create a droplet. Why is it running slow today? And in the droplet, I will choose the same thing. I want Debian, and I would like to get a 1 GB RAM. And here I'm paying $10, as opposed to here, I'm paying only $5. Why is the difference? There are a variety of reasons why that difference exists. It can be a business reason. It can also be that the machine is bad. It's a cheapo machine that they want to give you for $5 a month. It could be that. But again, how will you tell? You cannot really tell just by looking at the price. You have to actually exercise these machines on your workload. You have to put some load on it and run it and see which one performs better. That's the ultimate test. Otherwise, it is so hard to compare and contrast one cloud with the other cloud. You cannot really tell unless you put your application on these locations and run them and measure how quickly or efficiently they perform. And then you calculate and come up with your number as to whether this $5 is expensive or $10 is expensive for a comparable performance, not by the size.
No, I never thought of this.
Yeah, go ahead.
Okay.
Go ahead, I'll wait.
Sure. Yeah, I just noticed there was that really small machine on Vultr that was sold out. That was interesting.
Yeah, because they have a policy to not give you more than one machine per customer. So this is like a business case. It's a business situation. They deliberately keep it low. It's a what they call carrot. So I must have taken a machine somewhere in another region where they don't give me any more. So you can just create one $2.50 machine, one per account. And this is just their policy, right? So you just have to live with that policy. Most people will run applications like either here or sometimes here. That's common mainstream usage. Simple applications, other bigger usage you will go higher if you need to. And we'll show you where and how we go, in which direction we go, and how do we make that assessment of how big a machine I want. We just discussed up until now only these three things: CPU, GPU, and RAM. We also have to cover the disk part. The disk can be magnetic. Don't use it. They give you choice to use magnetic disk. There is no reason, as far as I think, to use a magnetic hard disk. There's absolutely no reason I can think of, unless you have
long-term storage.
Yeah, SSD.
Archiving.
Yeah, so why store in a magnetic disk instead? Store it in another type of solution. I'll discuss that later on, but there is a solution. A magnetic disk doesn't have to be that one. That's what I'm saying. So SSD is a preferred option, and that's where you should go. However, SSD can come in small or big sizes, small, medium, large, whatever size you want. You want to get GB or TB, whatever size you want, that's good. But next, the idea behind SSD is that it can also be fast or slow. And this metric is defined by the number that I was showing you here in Rackspace. Where was that? Here. So you can see that the IO performance is 120 gigabytes of IO per second. That's what the performance of this collection of disks would be if you choose that route and actually create a server by clicking this button. That's what you will get, and you will pay a lot of money for that. But then realize that you're getting a good damn hard disk, high performing disk. And that's what this characteristic is for a disk. And you typically don't get magnetic, and most companies are phasing it out. People are suggesting to use a fast or a slow. They don't call it slow, they call it the general purpose disk, general purpose SSD. They don't call it slow because nobody wants to call themselves slow, but it is slow. I mean, it's not really slow, but it's usable. That's how I would say. It's usable, it is cheap, it's available, use it. Fast, you have to pay for it. So there is money associated here. And then that was disk discussion. In addition to these characteristics, CPU, GPU, RAM, disk, you have one more characteristic that you need to think about. And do you know what that thing is? Begins with the letter
Resilience.
Huh?
Resilience, availability.
Yeah. So I'm talking more at the component level. So at the component level of a machine, what you need to worry about is the network bandwidth and latency. Of course, at a collective machine level, you talk about availability, reliability, serviceability, and all those things will come into play. But at the machine level, there is a network card. It has to have certain bandwidth and certain latency characteristics that has to be defined. So you have these cards that I was mentioning here early on. Where is that? So if you go to my network, you will see that I have this adapter called Wi-Fi adapter, and it is connected with this IP address. So that's one adapter. If I look at the terminal and look at my adapters, you will see a lot of them. They're not showing up here visibly, but I have a lot of adapters, and they have a specific purpose defined for their role in life. So lots of adapters defined, and they come with, each one of them will come with certain bandwidth number and latency number. And in simple practical terms, it will translate to you buying I think I have too much sun here in my face, so I need to shut that window down. I cannot even see anything right now. And you can probably not see me because the sun just came in my face. Hold on. I should shut the window down. I couldn't even see anything. I'm totally blinded. So this gigabit Ethernet. You may have seen this adapter that you can possibly buy in Amazon.com that looks like this. So you put this in the USB, and the other one gives you an Ethernet adapter, right? That's a network adapter. It's a consumer usage adapter. You will see some other adapter examples on a server machine that looks something like this. And you hook that up in a server, and you get two Ethernet output ports that are gigabit Ethernet output available to you. Sometimes some newer machines will have even higher performance, and those are 10 GB Ethernet. And that would look something like this. They'll look kind of similar, but the performance of the network itself is higher. You can carry 10 times as much traffic through the same cable and through the same adapter. And you can use this kind of a adapter card on a machine that you construct your underlying infrastructure with. And that gives you ability to provide a higher speed network on your machines that you will be serving in your cloud. So that's how I think about these underlying components that I just described. Now, how do we next take these things together and then formulate? What I would like to suggest is to carve out small machines out of big gigantic boxes. So if I can get a big gigantic machine that would have hundreds of terabytes of storage and say 256 core CPU and some exorbitant amount of RAM. Even more these days, I think it's even bigger available. So if I have this kind of a machine, and I will have like 10 of these guys sitting back to back in a rack, mounted and ready for me to start exploring with my private cloud deployment, how do I then create a setup which will allow me something like this, that allows me to select and allow my customers to select a small machine, a big machine, a slightly bigger machine, things like that, 20 GB machine, or a $200, $80 machine, 200 GB SSD, 6 CPU, 16 384 MB memory. So that kind of a machine, if I want to create, how do I create that with these kind of setups and multiply by 10? So I have tens of these big gigantic machines sitting in a rack, ready to power on. Now what do I need to do to make this kind of a setup available to my internal customers? What do I need to do? First thing, I need to run an operating system in each one of these guys. They need to run an OS, some kind of an OS that supports virtualization. And most of the time, almost except Microsoft Cloud, almost everybody runs Linux. Microsoft will run, of course, Windows. And in that operating system, you get the ability which is known as a hypervisor. A hypervisor is kind of sort of like supervisor, except supervisor is on top, hypervisor is on the bottom. It's managing from underneath as opposed to managing from top. Supervisor is the big boss in your organization. He or she is supervising. And you have the hypervisor, which is the big boss under the hood, manages from within, from underneath. That's how you should look at hypervisor. Now, what is it? What is a hypervisor and what does it do for me? And how does it actually help us in our discussion? That's what the next topic that we will discuss. So a hypervisor is basically creating fake computers. Out of what? Out of real computers. So it creates a fake computer, plural, S, multiple, more than one, out of one or more computers. So you have
a simulated computer.
Yeah, you can call it fake, you can call it virtual, you can call it simulated, you can call it whatever you like, but the problem is you cannot touch it. I mean, you literally cannot put your finger there because there is nothing to touch. All you see is this, is the power button, that one, the green one. And I can click on it, but I cannot really touch it. That's why I call it fake. And so I have this hypervisor provided to me by this software called VirtualBox, which is an open source product bought by Oracle. So they have the Oracle logo here, but ignore the Oracle logo. It's an open source product. And this is the underlying solution that I'm using to provide hypervisor capabilities on my laptop. It is for an individual to use. This is not what the cloud companies use. Cloud companies will use something else, which is they call a proper hypervisor. So I'll now talk to you about what a proper hypervisor is. A proper hypervisor is one of these guys. So this is one, the Zen project. And I'll open a couple more while the site opens. The other one is KVM project. And more.
VMware, Hyper-V.
Yeah, VMware and Hyper-V are commercial products. So I don't tend to bring them, but now that you have, I will bring them up. They're commercial, they're not open source. So here we go, VMware hypervisor. And Hyper-V hypervisor is a Microsoft technology. And that is also conceptually the same thing. So you have the Zen hypervisor, the Zen project, which is open source. This is how Amazon is basically built, using this hypervisor. KVM hypervisor is another open source project, which is also tremendously popular. Just about everybody else other than Amazon uses KVM. It's Red Hat based. So Red Hat and Ubuntu and all of these open source projects actually use this. And VMware is a commercial product. It is also available on Amazon Cloud and a bunch of other clouds and VMware's own cloud, and it's commercial, so we don't talk too much about it. And this is also another commercial product called the Microsoft hypervisor, known as Hyper-V. And there are more, by the way. So we can go see hypervisor and search them. Generally speaking, you can have some examples listed out here. So let's see some examples. Yeah, there is a Citrix hypervisor, there is a Citrix Zen desktop, VMware Horizon View, Altio Open Virtual Desktop, OpenVZ, FreeBSD Jail, lots of things.
Does Apple have one?
Apple has a hypervisor. So Apple as a OS doesn't give you to consumers. I think Apple OS has, I'm not sure, I have to check. Let's ask this question. Apple OS X hypervisor, does it have any? Let's go find out. Apparently they have, but I never read it because it is probably not open source. Okay, they have it. com.apple.vm.hypervisor, supported hardware, VM lifecycle, create and destroy. They have it apparently. So I never used it. I don't care about it. Bye. Sorry. The other open source projects are right here. You can list, find them listed here in the long list. Some of them are open source. Like this Beehive is open source, I remember. QEMU is another one. This one is good. VirtualBox is open source. QEMU is open source. Parallels has a commercial product. VMware, Windows Virtual PC. So yeah, these are the players in the industry. All they basically do is give you fake computer, virtual computer, simulated computer that looks and behaves just like a full computer, but you cannot hold it in your hand. It has every single thing you can think of. And in fact, I'll create one right now. So let's go do this. I'll create a new computer. And in there, I will say, I want to run Windows in here, right? So if I want to run Windows, I need to have the Windows OS CD or ISO file or a USB stick containing Windows 7, if I like to choose that. Or if I want to use Windows 10, I can choose Windows 10. Or if I want to use Windows Server, I can choose Windows Server. My choice. And then I have to give it a name. So I'll call this my Windows fake machine. That's the name. And this is going to run Windows. I can choose other OSs if I like. I can run any OS I want. I can just pick and choose. But I right now in the mood of running Windows. So I go ahead and say continue. Then I get to choose how much memory do I want to allocate to this Windows machine. I have a totality of how much? 16,384. You can see right there. That's the total amount of RAM I have here. In the total machine memory, I have, how much memory do I have? Should show you that. Yeah, 16 GB RAM. So total RAM available, 16. That means I can give it a little bit more than 2 GB, maybe 8 GB, maybe a little bit more. And if I go beyond the red line, I'm causing trouble for myself. I'm causing trouble to my underlying operating system will basically behave improperly if I go beyond the red spot. And I'm about to cross it. It will still let me create and go ahead, but it's in the red area. It is danger zone. So you don't allocate too much memory to a virtual machine more than what the underlying hardware can actually sustain and tolerate. So you want to stay in the green area. So maybe I can decide that I want to give 8192 MB RAM, and that is good enough. So half the memory allocated to the Windows machine, that is going to be created. And the remainder half, 8192, is going to stay with the Macintosh. So now I continue. Now here, my total disk size available to my machine is how much? Total storage, 1 terabyte total. That's the totality of my disk in my computer, this one. Now in this machine, I can choose that I create a virtual hard disk right now. So I say, okay, create one. The recommended size is 32 GB, but I think it is too small. So I want to create a big one. So I'll create a continue. There are 3 types of machines, 3 types of disk formats available. The first one is the VirtualBox format. The second one is the Microsoft format. And the third one is VMware format. 3 formats available. I choose the first one because it's the native VirtualBox format, the open source format. That's what I like. So I choose that one. Second is Microsoft format. Third is VMware. So we are not choosing those, but we proceed. Now here, I'm choosing dynamically allocated. And then I decide that I want to give it some more hard disk. For example, 2 terabytes. Is that a good idea? I have only 1 terabyte. Can I give it 2 terabyte to the Windows machine? Or rather, let me ask you this question. It is not a question of should I give 2 terabytes to a Windows machine because I need it. So the should part is taken care of. The question is, can I give 2 terabytes to this Windows machine? I have only one.
Yeah, if you don't have it, you can't give it.
Well, I think I can. And so I will. And I'll tell you why. And I will actually allocate 2 terabytes. And here we go. And it succeeded.
Thin provision, right?
Sorry?
Thin provisioning, or how are you doing that?
Exactly. You got it. Thin provisioning. That's the exact idea. I am faking that I have 2 terabytes. I'm not really giving it 2 terabytes because I don't have it, but it's dynamically allocated. So if you go look at that disk again, here, it is showing you a 2 terabyte disk right there, but the actual size is 9 megabytes. That's what a dynamic allocation is, dynamically allocated storage. So I can make Windows believe that I gave it 2 terabytes, but in practice, only 9 megabytes right now. It will grow, and it cannot grow beyond the actual limit, 1 terabyte. If it grows beyond the 1 terabyte, the machine will crash.
Right.
But Windows will believe that it has 2 terabytes, and it will comfortably run until some point, which is okay with me. So that is dynamic allocation. Now, having discussed this briefly, what I just did is created my Windows fake machine right there. And in that machine, I have 8192 MB of memory. I have a floppy disk. Who cares about floppy? I'm going to remove that. So in my storage, I think I should disable floppy, but yeah, there we go. Floppy removed, optical removed, hard disk I want to keep. The boot order is stop hard disk, and I want to put a processor, and I have 8 CPUs, so I can give 4 to Windows. And then I will enable physical address execution, no execute bit. This is a specific property of the underlying Intel Core CPU architecture, which prevents it allows physical address extensions and no execute bit. This NX bit means you cannot execute code that is supposed to be data. So if you have some data written as data, you keep it as data, don't execute that bit. So no execute, NX bit is a bit set in the CPU that prevents execution of code that is supposed to be data. That's why I enabled that, so I get hypervisor capabilities inside my hypervisor. So this is a complex thing to comprehend. I'm talking about VM in a VM. And once you check that box, this particular extended feature PAE NX box, you can then run VirtualBox inside VirtualBox and create a small little machine inside a big fake machine in a real machine. VM in a VM. It is dreadfully slow. Don't try that, but it will work. It's horribly slow, but practically possible. I mean, barely usable, but possible. Just saying. And so this motherboard, I can select memory, I select my disk, I can select my mouse pointer or tablet or whatever. I have a tablet, so it shows up as tablet. And so this tablet that I'm using, this one, oh, what just happened? What just happened? Yeah, I was showing you the tablet, which is what I'm using to write on the pen. And so then I can use some acceleration. This is the underlying hypervisor kicking in. It tells me that I'm using the para-virtualization interface. Here you can choose what type of hypervisor you want to simulate on. And you get to choose default, legacy, minimal, Hyper-V style, and KVM style. You have choices available, and this is specific just for VirtualBox, which nobody in the cloud uses, just so you know. It is just you and I using this machine for a demonstration. Actual cloud people will use these kind of tool sets, and this, most of them, and some use this, and some use this. So those are the examples for what we are discussing is the underlying ability to create small, or rather smaller, fake virtual machines out of real physical machines. And here you can even have a display and display memory allocated, 128. And you can have a remote display connected if you like, or video capture to record a video or whatever you do inside the VM, but this is consumer focused, not cloud focused. So moving on, we have storage. We saw already discussed the 2 terabyte hard disk, which is not really real. It is make-believe dynamic allocated thin provisioning. Audio card. This is again not relevant for cloud. You don't have a sound card, but in here it is. You can actually play music in the Cloud Genius workstation. You have some network cards. These are 4 network adapters, 1, 2, 3, 4. 4 network cards available in the VM. Only one of them is currently active, so I can activate others if I want, like this. And I'm basically adding 4 different NIC cards. 4 NIC, NIC as in here. Let me show you what I mean by NIC. I think you know it, but this is a NIC. I just added 4 of them to my fake machine, like this. Adapter 1, 2, 3, 4. Now, how do I wire them up? Connecting them, that is also possible. You can decide how you want to connect. So the first one is attached to a NAT, and I'll talk to you about what these things are. These are slightly difficult to comprehend if you have never dealt with a network, but I will describe them. There are lots of choices, and so bear with me. Here are the choices, and I'll go walk you through every one of them so you understand, because this is critical to understanding network concepts as we take this same idea to the cloud. And you will get it once I describe this. It's super easy to understand if you think as to what you do. And I'll give you more examples in a subsequent step as we flow. But for right now, the default choice that you saw, adapter number 1, connected, enabled, attached to NAT. What is that? That's what I will draw now. So here, piece of paper and new sheet. Now imagine you're in your home, which you are probably most of you. And so in your home, you have a connection from a company like Quest or Comcast, some of these guys. Like, some random companies will give you some kind of an internet connection. They will give you some kind of a device. It is typically called a modem. And in that modem, you get one IP address. The most homes that you have will have multiple machines, iPads and TVs and God knows what. So you have it, but how can you then connect all these guys to this one IP address? You need to have something else here.
NAT.
That thing is NAT.
Yep.
And so with this NAT, what it does is gives you multiple connectivity to Wi-Fi and Ethernet and all those things that you're probably familiar with already. So this NAT is also called a router. And that's what you typically buy. You buy. This Comcast will give you sometimes for free. Sometimes you buy it. Sometimes they charge you an arm and a leg for monthly rentals, but that's a bad idea. But don't give them rent. Don't rent them, but buy your own modem is a good idea, and keep it. And so that modem gives you only one IP address. Then you have to have a router that gives you either wired connection or gives you Wi-Fi connection. So what I'm talking about here in our example is that the adapter number 1 is connected via NAT. So where is this NAT coming into picture? So this NAT is basically also simulated inside this hypervisor. In this virtual box, there is a NAT. It doesn't have a place to see, but I can show it to you where exactly it is. It is actually hiding somewhere here. Network Operations Manager. That's no. There is somewhere. I'll identify where exactly it is. I'm forgetting where it is. Network. Yeah. So here it is. So there is a NAT network and a host-only network built into your virtual machine hypervisor software. What this does is gives you a fake router. So like we discussed, you buy a router for your home, and a modem for your home, and you have the Comcast company giving you internet. And so this NAT device is commonly known as router, is actually a NAT device as well. It has multiple other functions together. NAT is just one of the functions. The other function that typically is available is a DHCP server. And sometimes you have other things like a firewall and other things built in together, collectively known as a router. But right now our focus is just the NAT part. So that NAT is what is built in right here. And there is a network called NAT network, and there is a network called host only network. So let us see how these are connected. In this fake Windows computer, if you go to settings and go to the network section, you have one adapter, number one, connected to the NAT device. That NAT is connected just like this. I'm going to go back to my eraser, erase some of it. And imagine that you have a real home, which you do. You have a router, which you do, and you have your desktop, which is your home computer. And on that desktop, you have this hypervisor running known as VirtualBox. Now, in that hypervisor, you have a NAT right there. What does this do? You have this connector connecting and giving a separate network created, all fake, nothing real here, no cables, all inside VBox, and create multiple network endpoints where you can actually hook up adapters, A1, A2, A3, A4, like that. And it is another layer of NAT behind this NAT that you already have in your home. This is your fake NAT. It's there inside the VirtualBox application. And that is how one of the adapters, number A1, is connected to this NAT in your VBox, in your desktop, laptop, whatever you have. So in my case, I have the router, which looks like this. And it has a bunch of machines in here. And this is my public IP right there. And my laptop that I'm looking at right now is one of those machines. Which one is that? The MacBook. So this MacBook that you can see here is the machine that I'm looking at. And so let's go exit out and look at my Wi-Fi adapter IP address. You can see that I am receiving a 10.0.1.4 IP address from this router. And now this 10.0.1.4 is actually the machine IP address that I have for this network, which is showing up here. And that is the physical machine IP address. However, this fake machine will not get that 10.0.1.4 IP address if I start it. In fact, there is no machine, there is no OS in the fake machine. So I cannot start this machine right now because there is no operating system. If I attempt to start, it will say OS not found, or give me a disk to boot from. So I don't have it, so I can cancel it. But close and power off. And see, the power off button was there, but I could not hold it in my hand, only through mouse. So it's all virtual. Now, this machine is actually functional. I can start it and check out its IP address, and you will find it is not this range. This, sorry, wait for it. So this 10.0.1.4 is the IP address of the real computer I have. The virtual machine that you will see coming up shortly will not have that IP address range at all because it is behind a NAT. And you will see it. This CloudGenius workstation is behind that fake NAT. This one. It is somewhere here. And that's what this CloudGenius workstation is. It has an IP address issued by this NAT device, which is not this NAT device. So it is a different subnet. And I'll show you exactly what I mean when I open it. So if you'll see here, this guy has an IP address of 10.0.2.15, whereas the machine here has an IP address of 10.0.1.4. So it's a different subnet. This subnet is operating at 10.0.1, whatever the number you like here in my home. You can put any number here as long as it is in between this range. You can put any number you like, and you can see some of that in the airport, where it will read and settings and show me the IP addresses. And so the range is 10.0.1.1 subnet. So all these machines in my home with multiple laptops and iPads and God knows what, they all have a subnet that looks like 10.0.1 whatever. That's the NAT that I have for real. Now this NAT is a fake NAT, and it gives me an address of 10.0.2.15 for this machine running on this virtual machine, connected to the adapter A1, connected to the fake NAT, which in turn is on the physical box, which is my MacBook. That in turn has a 10.0.1.4 number, 4, as opposed to whatever I choose. So it gets dynamically allocated, and that is the real IP address from a real NAT. But this is different from this. This is 1, this is 2. It's a different subnet. So it creates a private isolated subnet behind another fake NAT and assigns it an IP address underneath. The reason is simple, because I've chosen my network adapter to be attached to NAT. That is why I get a 10.0.2.15, and it has no connection to this subnet. It has connection, a routable connection to my home and my internet outside and all that, but it's a different subnet. Now, if I decide to rewire, and I will do that rewiring right now. What I will do is, and watch this very carefully, it's kind of hard to understand if you have never done this before, but I'm going to rewire some of these cables. They are fake cables, and I will rewire them. And I have just one adapter right now. It is connected to this Cloud Genius workstation, and it was, come on, pen 2 here. And this adapter A1 was connected to my NAT. That's how the connection was, right? You can check that again back here in the settings for Cloud Genius workstation, Cloud Workstation settings, network adapter number 1 attached to NAT. That's the fake NAT I'm talking about. Now let us switch this to bridged. And this is the careful part. Watch it carefully. Bridged adapter. And I just changed. And I'll say OK. Now I just dynamically reconnected my cable from, I broke this, and I said, connect it right here. That's what I just did. So I broke this connection. This adapter A1 is not connected to my NAT, but instead connected straight to the router, the real router, bridging to it through the Wi-Fi adapter I have. So let's go check again. Setting, network, adapter 1, bridged adapter to the Wi-Fi airport, and OK, right? You saw that. Now let's go to the machine. And here we will do a reset on the network. I think I may be typing mistake or maybe forgetting the command, but I think it's probably networking or network. I'm just resetting the network service. I think it's networking. networking. Yeah. So now we should have a new IP address already. So earlier it was 10.0.2.15, like there. Now we will go and find out the new IP address. Oh, maybe it needs a reboot. So I will reboot and wait for it to come back online. This virtual machine should come up with a new IP address from my real router. Next time this boots, you should get a new IP address assigned to it from the airport, from this guy. And let's wait for it to reboot, and we should be able to see that new IP address provided by the airport to this machine, because I rewired it. I rewired it like this, like the green line. From here, not go to NAT, but instead go straight, bridging all the way to the real device. That's how I bridged it, and I'm expecting to see a 10.0.1 dot whatever number for this machine. That's what I'm expecting, and I will go and see what actually happens. So we'll go here, and what just happened? Kernel panic, did not reboot properly. Okay, power off, and power off the machine. Start it again. This happens occasionally in live demonstrations, just so you know. So I'm still bridging to the airport, and I should now power it on, start. And I hope it doesn't panic again on me, but you get the concept. The concept is simple, that we are connecting straight to the Wi-Fi router outside this fake environment to the real router, this one. And so it should give us a 10.0.1 dot address as defined in this LAN IP address range. That's what I'm expecting and hoping that it actually boots properly. And come on. Yeah, it'll come. I'm not worried. But you get the concept. That's how you can rewire network components inside a virtual environment. And we'll do some of this in a variety of cloud setups where it is difficult to digest unless you see this demo as to what is going on under the hood. These network components can be rearranged, rerouted internally in a soft fashion without actually holding wires in the hand. There is no wire I held. I just held my mouse and I rewired it according to what I want. And I hope the demo will succeed, which I think it will, but you get the concept. And so that's what underlying virtual hardware is under the hood in a variety of cloud setups. And that's what you see in practice in actual deployments. And where is that guy? Our Zen, XEN hypervisor. This company and the KVM project, those two hypervisors are super popular, used across left and right across the board in most clouds. And they give you these components, these capabilities to reroute traffic as you need. Let's go back here. The machine is up. We'll start our command line, find out its IP address. And what do you see? 10.0.110. I am directly connected to my home network on this fake machine because you know why. You know why. Because this rerouting. I can, of course, break that route and say, you know, you better stay where you are and you connect to the NAT. I can change that. There are other ways to do things. For example, there is a thing called not connected. Like I'm not connected. So when I'm not connected, I am not connected. That's a choice. And you can see that choice here. Not attached. That's the choice where you don't connect it at all. And when you don't connect, it is not connected. It's there, but not connected. Then you have a NAT choice, a NAT network choice, a bridged adapter choice, an internal only network choice, a host only adapter choice, and a generic driver type. So lots of choices to understand. But again, remember, this is not cloud focused. This is just pure a local private one individual developer's machine hypervisor for a individual developer. This is not focused on cloud usage, but gives you the concepts. That's the reason I'm bringing it up and we use it, because we are all individuals and we will have machines ready with us. That's our foundation with as we play along. So this is how you rewire a network, and these network adapters are available, at least 4 in number, 1, 2, 3, and 4. And you can rewire them as you feel like, as you want, and rearrange the network as you go along, and click. And it will now again get the 10.02.15 address from the fake NAT as I reboot. And I think that hope clarifies these concepts from machine component level as to what it boils down to from a usage perspective. And I want to pause here right now to ask questions, or rather let you ask questions as to what do you think we did today? How was it? Was it useful? Was it easy to understand? Was I too fast? Was I too slow? Was I speaking in Indian accent? Which I was. I'm sorry, I cannot fix that. But apart from that part, was I easy to understand? Was I difficult to understand? So I need to get some feedback. That's what I'm waiting for. So I want to hear from you. How was the session today? How did I do?
Perfect. You're easy to understand. Good information. Thanks, Nilesh.
Was it useful?
Yes.
Was it new?
Many parts were new. The definition of cloud was new. So I'm glad I have that under my belt.
Okay. Okay. Good to know. Good to know. And I encourage, of course, anytime you have a question, you please ask. Now what I will do is not make the recording too long. So I'm going to stop the recording so that it creates a video file, and I'll then tell you. So let me pause the recording right now.